Good evening, all of you. Yes, Pallavi, number of bushings depends on if it is single phase transformer. No? For example, primary two terminals we have, secondary two terminals means LV two terminals, HV two terminals. So total four. Like that, if it is delta delta. So if you take delta delta, how many wires will come outside on each side, primary side and second side? Three terminals here and three terminals here. Total how many will come? Six. Like that, if it is delta star. Here neutral also we take outside now. Then four terminals will be there secondary and primary side three. Total seven like that. Okay. Anonymous attendee. Thank you. What is your name? Bushings, not bushes, bushings. What is the purpose of bushing? This is a insulator, no? Because transformer winding is inside, but you are taking that terminal winding outside through what these bushings on. Okay, through these bushings. See, from the inside, there is one metal pin will go here inside. This is inside the tank. This suppose this is LV winding two terminals, no? One terminal connected, and through this bushing inside it is coming, and here this is outside. This is outside, and this is inside. This is LV winding two terminals, and one more bushing for other side. It will come outside like that. Thank you, Jadov. What is your name first? Anonymous attendee means test will be there after. I don't know when the test they are conducting after every subject, and after completion of total syllabus also will get again grand test will be there. So after completion of each subject also you will get one test will be there, I think. Parag Mehar. So I don't know what subject. Okay. Okay, you will get schedule, no? So whenever whatever the subject will be there, definitely you will get the schedule. Okay, Bhaskar, that will be there because at the first time little while reading, but try to listen in the recorded video one more time so that all. What is your name first, Anonymous? So revision class will be not now. That will be in the last year we taken in the month of June before examination. Maybe like that only you may have revision, but that revision also most just in short, briefly we discuss all the topics at one time. Thanks, Ravi. And from your batch, I observed most of you regularly attended. That is good. So that same type of zeal should be there up to the entire syllabus is completed. Okay. So don't leave any subject. Listen all the subjects. Okay. But before examination, like 2 months or 1 month before, at least 2 months before, you should be perfect in minimum 6 subjects. Whether you are reading all the subjects or not, that is second, because electrical people particularly, they don't read all the subjects, they don't be perfect in all the subjects. They will perfect those who want good ranks, like uh, good one. Then you should have minimum 6 7 subjects be perfect. Minimum 6 subjects, like network theory, control system, mathematics, machines, power system, measurements. Okay, at least these 5 6 subjects you must be perfect, and then go the remaining subjects briefly once, but don't leave any subject. Don't leave any subject, go briefly with other subjects also, because each and every subject, if one question also, if we are getting that, one question will decide us, decide our future. Okay, don't neglect it. Yes, before Jan, mostly all syllabus total subjects will be completed, no doubt. Your class strength, particularly in this batch, it is more than 500. So don't neglect any machine part, not only transformer like DC, synchronous, induction. Don't leave any part. Everything is easy only. Nothing is difficult in machines. First, be perfect in notes itself. Enough. Be perfect in complete notes. So I am guarantee you will answer out of 100%. Suppose given 10 questions, I am guarantee if you read only the notes, 7 8 questions from notes only will solve. No doubt in that. But for that 1 or 2 questions, you need some other practice from standard books. But if you don't want that, at least 8 marks out of 10 questions, if you are answering 8 questions, means the best one that is. Okay. Okay, thank you all of you. But only one thing I observed while reading any topic or any subject, don't try to bring many doubts from you. Don't try to create many doubts there. It will damage us. Definitely, it will damage, because we want to get a good rank and we don't want to become a scientist. Okay, scientists also will not think like this. Whatever subjectual or subject wise, whatever we need to learn for our numerical problem solving, learn up to that and leave. Because once you got any good rank, tell me, after getting a good rank in GATE or ESE, suppose, uh, do you remember the subject? Definitely, you will forget the entire things, no? Okay, so be like that only. Yes. Yes, those who are in second year, still you prepare for GATE 22 first, because if you are pointing to GATE 22, by GATE 23, definitely you will become more shine compared to 22. Okay, so don't take that much time, because if 23, if your target means, definitely you will forget, I think, in between the most of the subjects, right? 22 and also take 23. Then in 23, definitely you will get a better rank. Just like practice, you can consider GATE 22. Okay, there are so many, more than 100 messages. So sorry, I cannot read all of you. Yes, anytime you can ask. Uh, Particularly for transformers, sequence means there is no sequence, anything you can read in machines, any topic. But for transformer, you no need many basics like rotating machines. Rotating machines, we have additionally Fleming's right hand rule, left hand rule. So these are all well we should apply in the figures that you should know well. But here we are not learning anything. So for transformer, that many basics not required. Only some magnetic concepts and electric circuit concepts and Lenz law and Faraday's law enough. But if you go to rotating machine, Fleming's right hand rule, left hand rule based on generator motor that you need to understand well. No, I don't want to give any background because I don't have any big backgrounds. So I'm not interested also in that. So I want you people should create a good background for everyone. Okay, Jitender, backgrounds are not important. Particularly my background not important. So you create a good backgrounds. Okay. Shafia Sultan. So I don't know about it. Okay. Okay. So first I need to complete the today's topic. If time is there at the last, we'll talk again. Okay. Thank you, everyone. Thank you. So let's continue. So yesterday we have seen parallel operation conditions. Conditions for parallel operation. We have some necessary conditions and also desirable condition. Desirable means whether it satisfy or not, you can operate. But if it is also satisfied, you will get a best parallel operation. Okay. Now, next topic in the same parallel operation is load sharing between two transformers. So they will give two transformers, and what is the load shared by transformer A or transformer 1? How much it will share when you connect some load in the two transformers. So only that type of numericals that we have in case of transformers in parallel operation. But if you go to alternators, in alternators, parallel operation topic is very important. So there you will get so many subtopics in parallel operation of alternators, but in transformer we don't have that many. Okay, right siding two transformers in parallel. Two transformers in parallel. Now let us consider equivalent circuit of two transformers connected in parallel like this. Transformer A. What is this circuit is? This is the transformer circuit referred to secondary. So generally we are drawing like this. Okay, if you remember, this is our transformer secondary EMF, and here we are connecting load. This is the single transformer. Okay, now I am drawing the same like this because two transformers I need to draw. That's why I'm taking in this way. Okay, transformer A, and like that transformer B, I will take two transformers. What is this circuit? Secondary, refer to secondary. Transformer circuit refer to secondary side. Connecting two transformers in parallel. See, two transformers connected in parallel. Now we will connect a common load. Same load we will connect two transformers. Transformer A, let secondary side na E to A it is, and this is E to B. And overall impedance of transformer ZA, RA plus JXA. This is overall impedance ZB, RB plus JXB, we call total resistance and reactance. And it is the voltage across load, let V, and current is IL, load current. Okay. And load KVA means let SL equal to V into IL, volt ampere. KVA rating or volt ampere rating is voltage across the load and current through the load. Now let this current is IA, current shared by transformer A. and current shared by transformer B. And sum of these two is nothing but IL. IL equal to IA plus IB. Okay, IA plus IB. Now same circuit, I am little simplifying and drawing here. How it is? What is these two voltages? Same only, no? Voltage rating should be same for two transformers. E to A equal to E to B. Okay, both are same voltages. That's why I will combine both as single source. So that the circuit will little simplify here like this. I will combine both as single source because both voltages are same. Now simply I will get this one RA, XA, RB, XB. So over ZA, ZB it is. Both are same or not? Yes, both circuits are same. This is E to A equal to E to B. Both voltages same. That's why I combined as single source it is. Then this is ZA, ZB, and total current is what? IL, same current. Sum of these two current IL here, same current it is. This is individually IA, this is IB, and voltage across load consider V, terminal voltage. This is load. Okay, both are same, both circuits are same. So here we are discussing in two transformers operating in parallel with equal voltages. Okay, with equal voltages only we are discussing right now, because with unequal voltages also we have one more case, but we are not discussing that is because it is so much lengthy questions or not at all possible to give in objective type. We don't have in syllabus also for gate. For engineering services prelims, this is only we have, and only in conventional questions. So those who will attend again in conventional classes in the after maybe next year only, that you will listen, the people who joined for engineering services. So there we will see about unequal voltages. There E to A is slightly different, not equal to E to B. That is unequal voltages we call. Okay, but anyhow we are not seeing this is not. With our equal voltages only we have the numericals. Now tell me from this figure. This is just network analysis, your network theory. In the network theory, total load current is total current is IL. Then how to find current in this branch A? What is IA? How can we find? Current division rule, no? So we need to find here how much current or load shared by transformer A and load shared by transformer B. Load is nothing but currents. So that currents IA, IB we need to calculate. Okay. Right. Completed the figure. Next page. Load shared by transformer A. Write it. Load shared by transformer A. Transformer A. So this is I'm writing as current first. Load is nothing but current shared by transformer A. Both are same. Now what is the IA? Tell me how to find this IA. Current division rule I am applying. Total current is IL. Total current here IL. Then IA equal to IL into ZB by ZA plus ZB. So hope all of you know this current division. Okay, IA equal to total current IL into ZB, opposite impedance, by total impedance. So same I'm applying here. IA equal to IL into ZB by ZA plus ZB. Okay, by applying current division, I'm writing directly this. Next, this is load shared by transformer A. Now let us multiply on both sides with voltage. V into IA. This is also V into IL into ZB by ZA plus ZB. Now what is VIA will become now? Volt ampere rating. This is VIL, volt ampere rating. But this is load side and this is transformer. Therefore, the load shared by transformer A is taken as SA equal to, and this is we call SL into ZB by ZA plus ZB. So use this equation to find the load or KVA shared by transformer A. So sometimes in questions they will ask directly load shared. The same thing, KVA shared by transformer A. Both are same. KVA shared or current shared or load shared. Same it is. Transformer A. The formula is this: SA equal to total KVA. They will give in the question into ZB, impedance of transformer B, by total impedance of both transformers. Okay, this is SA. Now in the same way, calculate for transformer B, applying current division rule right below this. Similarly, load or KVA shared by transformer B. Transformer B. What it is? IB equal to IB. Current shared by transformer B. IB. Same. Total current IL. What is the opposite impedance to B here? ZA. So ZA by total impedance. IL into ZA by ZA plus ZB. So when you write current IB, take ZA. When you write current IA, take ZB. Like SA, if you want, SL into ZB by ZA plus ZB. Opposite impedance you have to write at the numerator. Now multiplying on both sides with voltage for this also, VIB equal to VIL into ZA by ZA plus ZB. Okay. Now this is SB equal to SL into ZA by ZA plus ZB. So writing in the next page. Yes, current division rule. Right. That is SB equal to SL into ZB by ZA by opposite ZA by ZA plus ZB. Okay. Remember these two equations. So only numericals from parallel operation is this is only. You need to find SA, SB based on the question they asked. So that questions we see some models. SB equal to SL into ZA by ZA plus ZB. Okay, remember these two equations. Load shared by transformer A, load shared by transformer B. Okay, make a note below this. Note. So it is regarding these two equations. What is SA? We got SA equal to SL into ZB by ZA plus ZB. Transformer A KVA shared and transformer B KVA shared. Okay. Now in these two equations, whatever impedances are there, whatever we have the impedances in questions, sometimes they will give impedance in ohms. Transformer A impedance is some 0.5 unit, 5 ohms. Transformer B impedance some 0.4 ohms, like that. And sometimes the same impedances they will give in per unit. Per units. Transformer A having 1 per unit, transformer B having some 0.8 per unit. Then calculate the load shared by two transformers. So whenever they given in per unit, you need to take care of this. That is, in these equations, you should not substitute that impedance directly. So first, take the note point, first point. Note, if impedances are given in ohms, if impedances are given in ohms, then substitute directly in above equation. Then substitute directly in above equation. Above equations. Directly you can substitute and solve. No need to check anything. Directly you can substitute if it is in ohms. But sometimes they will give impedance in per unit. Then directly you should not substitute in this equation ZA, ZB values. Then how to substitute is, observe, first write the point. If impedances are given in per unit, impedances are given in per unit, then convert convert the impedances convert the impedances to a common base kVA kVA. See, when there is per unit system, in per unit system, suppose there are so many transformers. One transformer rating 10 kVA, other 20, other 30, other 50, or other 100, like that. Different. But in per unit system, this is not applicable with the different kVA ratings. Now, what we do in per unit system is all different kVA ratings are there. Now, we will consider any one kVA rating. Suppose there are 10, 20, two transformers, 10 kVA, 20 kVA. Now, I will consider 20 kVA is 1 per unit. 20 kVA is 1 per unit. Now, you need to convert the impedance of remaining both transformers to this common base kVA. So we will take one base kVA when there are different kVA ratings in per unit system. So about this per unit system, you will listen clearly in the power system. So there, that is one subject, one chapter completely, per unit quantities. There you will get everything. We will take one base kVA. Okay. So simply remember here, if impedances are in per unit, then convert impedances to a common base kVA. Okay. And then substitute in above equation. Now I will give one example also, how they are giving, how we need to convert it. Just observe. So there is one formula, remember this, new impedance calculation, Z per unit new value. If you want to find new per unit impedance, see, use this formula, Z per unit old value into kVA rating or volt ampere new to the volt ampere old. Okay, use this formula. Actually, voltage ratings are same. That's why voltage rating we are not considering in this. Only volt ampere rating of transformer. So I will give example to understand this clearly. Take this formula first. New per unit impedance of transformer is equal to old value into new kVA rating divided by old kVA rating. So I will give one example how to convert it. See, for example, given two transformers, one is 10 kVA and other is 20 kVA. 10 kVA, 20 kVA transformer operating in parallel, supplying a load. And transformer A is having impedance of some 0.4 per unit, and transformer B is having impedance of ZB equal to, let's some 0.3 per unit. For example, like this given. Now they will given a load of some, let 25 kVA, for example. Load kVA is this much. When you connect a load of 25, in the 25, how much A is supplying, how much transformer B is supplying, we need to calculate. For that, you need to use these equations, these two equations. Okay, SA, SB. Now, while substituting in that, you should not substitute these impedances value directly, because these impedances are in per unit. Whenever it is in per unit, you need to check they given same kVA rating or different. If it is different, you need to take a base kVA. One common kVA you have to take base. So out of these two, anyone you can take. So I'm taking, let base kVA equal to 20. So I am considering this is my base kVA. So as I taken base kVA is 20 now, then for transformer B, impedance will not change. It is remain same, 0.3 per unit. Keep it is same because 20 we taken. So already transformer B 20 only. So ZB is directly same. But ZA you need to change. It is given for 10 kVA. This is the old kVA. Now we taken new kVA how much? New one is 20. So we are following 20 kVA is base. Now with respect to 20, what is the impedance of transformer A? Double. Or you can use direct formula. What is the formula? New value equal to old value 0.4 into new kVA rating. What is new kVA? 20. 20 into 10 cube divided by old. What is old volt ampere rating? 10 kVA. 10 into 10 kVA. So this is 0.8 per unit. Now these values ZA, ZB, you need to substitute in the formula. Okay, like this we need to convert on one common kVA. Clear? But if it is in ohms, you no need to do all this. Directly substitute. So we will see that numerical. See, S is inversely proportional to Z means this is a condition we have to use. How it is? Is directly we don't have any relation now. S equal to volt ampere, or you can consider S is VI. No? Now, how can we write current in terms of voltage of the transformer? V by Z. Then S is proportional to 1 by Z or V square by Z. Directly we are using this condition. Why this condition required? Impedance should be inversely proportional to kVA rating. What is this need of condition? To share the load based on their capacity. Suppose whatever capacity of transformer is there, up to that only it has to share, not more than its capacity. For that reason, this condition we are applying. While designing, we will apply this. We will design the transformer with high rating is low impedance, inversely related. If rating is required high, impedance of winding we should design with low. Okay. Yes, sir. They given per unit, but they given per unit for different kVA ratings. But in per unit system, all impedances you should have on a common kVA or on one kVA rating, some value. That's why we taken 20 is our common kVA. Okay. For transformer B 20 only, so same ZB. But for transformer A, given 10 kVA impedance is this much. But we are considering 20 kVA for that also. Then what will be the impedance of that increases? Okay, all these calculation you will get clearly in power system per unit quantities. But directly this formula is given. Remember this. This is the formula. New value equal to old value into new volt ampere by volt ampere. So this formula, how it is means there is a small derivation for this again. So you will get all this in power system per unit quantities. Okay, remember here. So let's see some questions on this. See this question. Yes, that new per unit values directly you can substitute. Yes, after getting new Z, directly substitute. That is only I given now in the note point. See, in this question, two 10 kV by 440 volt single phase transformers of rating 600 kVA, 350 kVA are connected in parallel to share a load of 800 kVA. The reactance of the transformers refer to secondary or so transformer A. Let transformer A. What is the rating they given? Transformer A rating is 600 kVA and its reactance. They given only reactance, resistance not given. Means resistance is negligible. They given directly XA. How much for transformer A? 0.0198 ohms. Similarly, for transformer B, the rating is 350 kVA and its reactance is XB equal to 0.0304 ohms respectively, neglecting resistance. The load shared by two transformers respectively means SA how much, because what is the total load given? Load kVA given 800 kVA. So SL equal to 800. So in that total 800 kVA, how much A is sharing, how much B is sharing, that we need to calculate. So here impedance direct substitution. Calculate SA/SB from this. SCA equal to SL is 800 into 10 cube into ZB means XB itself. XB 0.0304 divided by ZA plus ZB 0.0198 plus 0.0304. Calculate this SCA. Similarly, find SB value how much? What is SCA? Yes, 484.45. 484.45 kVA. And similarly, what is SB? Calculate SB value. SB. Yes, 315.5 kVA. 315.5 kVA. So these are the loads shared by two transformers. So total load connected 800. In that transformer A supplying 484 and transformer B supplying 315.5. So option A is right. Okay. See, approximately you can eliminate two options here. Approximately two options you can eliminate. These two you can eliminate. This one and this one. Why? Why it is? Because observe the impedances values once. For transformer A and transformer B, XA value is 0.019. XB value is 0.03. Means which value is greater? XB value is greater than XA value. Okay. Or ZB value is greater than ZA value. So if impedance is higher, what is the kVA shared by the transformer? reduces. If impedance is high, S is inversely proportional to Z. If impedance is high, kVA shared is less. So SB will share less. SA will share more. So out of A and D will be A or C. See, transformer A sharing is more. AC is there in that. Okay. Like this, at least if two options are eliminated, if there is no time to solve that value, then you can 50-50 chance. Yes, load shared by one of them may exceed. When it will exceed? If impedances are not properly designed. So I will show that question itself. Now observe. Next question. See this question. This is a 2 marks question, but if you properly understand the question, just 5 seconds your answer. Tell what is the answer. Just read. After reading, only in 5 to 10 seconds you need to tell answer. Two transformers are to be operated in parallel such that they share load in proportion to their kVA rating. Okay, the rating of first transformer is 500 kVA and its per unit impedance is rating of first transformer is 500 kVA and its per unit impedance is 0.05. If rating of second transformer is 250 kVA, then its per unit impedance should be dash. Based on what condition it is? See, such that they share load in proportion to their kVA rating. So this is our condition. So previously, yesterday I given one condition. In order to share the load based on their capacity, the per unit impedance of two transformers should be equal based on their respective kVA rating or based on their own kVA rating. Both should have same per unit impedance. So what should be the impedance of this one also? 0.05 per unit. Same it is. Answer is 0.05. Yes, right. Yes. Same per unit impedance. So this is direct condition statement. You need to understand the condition here and directly answer is 0.05. No need to solve. Next question. See, this is per unit impedance. This is per unit impedance. What is the condition? Suppose here they given that statement. This statement important. Okay, observe this statement. They need to share the load based on their capacity. That is our condition directly. Yesterday I said, if there are two transformers, in order to share the load based on their capacity, what is the condition? Ohmic value of impedance should be inversely proportional to kVA rating or this one. Per unit impedance of two transformers should be equal. So both should have same per unit impedance. Okay. Direct condition question it is. Next question. See this question. This is also 2 marks question, gate 15. Two single phase transformers T1 and T2 each rated 500 kVA. T1 is 500 kVA, T2 also 500 kVA are operated in parallel. Percentage impedance of T1 and T2 means percentage or per unit impedance. What is Z1? 1 plus J6 percentage or per unit. Z2 equal to 0.8 plus J4.8 percentage. Now to share a load of 1000 kVA, total load kVA how much given? 1000. To share a load of 1000 kVA at 0.8 lagging power factor, the contribution of T2 means how much transformer 2 will share, that is S2. So there we taken SA, SB like transformers A and B, but here given 1 and 2. Now S2 you need to calculate. Same formula. But here, once you need to check. Impedance is given in per unit, no? Per unit. Actually percentage, but directly I'm taking per unit, these values. Okay. This is given in per unit. So what I said, when there is per unit impedance, you should take a common KVA for both transformers. But here, anyhow, they given same KVA for both transformers. So no problem now. Directly we can substitute. Directly, because both having same rating now, 500, 500. Otherwise, if one is 500, if other is 700, then you need to convert. Otherwise, not required here. Already they given same rating. That's why per unit impedance, whatever is given, same you can take directly in the equations. So calculate S2 directly. What is the load shared by second transformer? Total load KVA into Z1 by Z1 plus Z2. Substitute here. S2 equal to SL is 1000 into 10 cube Z1 1 plus J6 Z1 plus Z2 1 plus J6 plus 0.8 plus J4.8. So add this, calculate this how much? Power factor no need to consider because directly this equation is with KVA rating. So we don't want that power factor. Directly you can substitute. Impedances they may give in per unit, they may give in ohms. Anything they may give based on the question or data given, we have to proceed. Calculate this. What is the answer? Ashwani, check one more time. Check the value one more time. Yes, 2. How much it is? Yes. Yes. No, no, check one more time. I think, yes, 555 is correct. 555.5 kVA, right. So here you will get 555.5 kVA or approximately 555 kVA. This is the kVA shared by second transformer. Calculate exactly. Numericals calculation should be perfect. 0.8 plus J 4.8 it is. J 4.8 it is. Check J 4.8. 1 plus J6 plus 0.8 plus J 4.8. This is 555 kVA. Now you can observe in this question how much S2 is got. This is only the answer for this question, 555 kVA. Now tell me what is the load shared by S1? How much S1 is sharing now? No need to use that formula again because already you have load kVA. Now S2 you got already. So 1000 minus 555. How much it is? Yes, 445. Good. This is 445. Now how much transformer 1 is sharing? 445. How much transformer 2 is sharing? 555. What is the reason for this? Now one transformer overloaded or not? Yes. Actual T2, each transformer capacity 500 only. But transformer 2 is sharing more than that 55 kVA. Additionally, it is sharing. But transformer 1 less than its capacity. Tell what is the reason for this? Because the impedances are not having same values. If they have same per unit impedance, then they will share equally. But now they are not sharing. The reason is the impedances are not properly given. Impedances are not proper here. That's why they are sharing unequal like this. Clear all of you know? Yes, good. Directly you can say T2 is lower impedance. Now this is 1 plus J6. This is low. Whenever impedance is less, its sharing will increase. That's why we got S2 more. Yes, good. Directly. If options are given, you can verify like this. You should have that T2 value more than 500. Yes, right. Clear? Next, one more question, lost in parallel operation. Read the question quickly. This is previous engineering services question. Quickly. 400 kVA, 11 kV by 6.6 kV, 50 Hertz single phase transformers gave following data when operated at rated current with their LV winding short circuited. Means short circuit data given when operated at rated current. Short circuit test where we conduct rated current only. Which winding we short circuit there? LV winding we short circuit. Test is conducted on high voltage side. So same it is. So they given there are three transformers. Each rating same ratings. 400 kVA, 11 kV by 6.6 kV. Single phase transformers it is. Mentioned single phase transformers. So given that short circuit test data for each transformer, short circuit test data. Actually, as ratings are same, test data also should be same or not? Yes, but because ideal is different, practical is different. No, practically maybe ratings of two transformers are same, but is the two transformers will give the same ratings or same losses or same efficiency? No, that's why they have different data. Now under short circuit test, what is that small voltage indicates? Voltage under short circuit or not? VSC that is. And what is that loss is given? Power is given. Watts loss, copper loss it is. In short circuit test, what are the readings we taken? VSC, ISC, WSC. And ISC they did not mention because directly they said it is at rated current. So what is the rated current on high voltage side? Rated current 400k by 11k. Calculate rated current how much? I rated equal to, calculate this. Yes, 36.36. 36.36 amperes. Okay, this is the rated current and VSC given for each one. Now for transformer 1, observe carefully. From transformer 1, if you have impedance and rated current, what is the, so you should remember short circuit test here. What is Z01 calculation there, or impedance calculation? VSC by ISC. Okay, like this we written voltage by current. So there is voltage here VSC, this is VSC for all transformers. Different voltages are there and different losses also there for three transformers. So I am utilizing this equation. Z01 impedance is nothing but voltage under short circuit by current under short circuit. So same I am utilizing. So impedance of transformer 1 equal to voltage 360, rated current 36.36. How much it is? Calculate. Impedance we are calculating first from the given data. How much? Yes, 9.9 ohms. Yes. Similarly, calculate impedance for transformer 2, Z2. Impedance of transformer 2, I'm taking as Z2. What is that? 400 by, same rated current is same in all transformers. Calculate this impedance. 400 by 36.36 rated current. How much it is? Yes, 11 ohms. Correct. Next, impedance of transformer 3. 480 by 36.36. How much it is? Calculate impedance. Yes, 13.2, right. 13.2 ohms. Now, from the impedance, what you are observing, tell me, different impedances. Which one is the lowest impedance? First one is having lowest impedance. Means if impedance of transformer is low, that transformer will become overload first, or that will share more. But read the question now. Read the question now. These three transformers are operated in parallel with with their primary voltage held constant at 11 kV. Okay, whatever it is. Next, first question. What is the greatest load at UPF that can be put on these three transformers in parallel without overloading any one of them? Without overloading any one transformer. Now, suppose you don't know all this. Generally tell, there are three transformers, each rating 400 kVA. Three transformers like this, 400, 400, 400. Now, actually, how much load you can expect? How much load we can connect? 1600, 1200. 1200 we can connect because 4 into 3, 400 kVA, three transformers. So total how much? 1200. So you can connect actually 1200 when it is, if it is ideal. But practically you have some different data, no? Based on that data, whenever load is increasing, load shared by three transformers is same? No, because transformer 1 will share more load because it is having the lowest impedance. So whenever you increase load, out of the three transformers, transformer 1 will reach the rated load first, will reach the full load first because its impedance is less. So like that, if you keep on increasing beyond that, now transformer 1 will become overload or not? Yes. But what is the question here? Without overloading transformer, how much it can supply? See, from the options, D you can eliminate directly. That is wrong. Why wrong? Each one 400. If you take ideal case also, 1200 only it can supply without overloading. So this is wrong. So less than the 1250. So out of these three, there will be the answer. So how to proceed for this? Simple. Based on the impedances values, which transformer will reach rated load first? Transformer 1. So let us take directly, transformer 1 will share a load of 400 kVA first. Full load. It will share 400 kVA. Now transformer 2, how much will share at that instant? Try to understand. Like these three transformers connected, transformer 1, transformer 2, transformer 3. A load is there here commonly. Try to understand this. 1, 2, 3. Three transformers. Now step by step I will increase load. 100 kVA load I connected first, then I will increase 200, 500, 700, 1000 kVA, 1100. Like that I am increasing continuously. Whenever load is increasing, the load shared by all transformers will increase or not? Yes, step by step increase. But which transformer will reach the full load first? Transformer 1 will reach full load first because its impedance is low. That's why it will reach full load. So once it reaches full load, then calculate at that time how much second is supplying and how much third is supplying. That's it. Because beyond that, you should not increase load. Okay, that's why I taken directly S1 is 400. Then how to find S2? How to find S2? S is inversely proportional to impedance. So using this relation, S2 by S1 equal to Z1 by Z2. Z1 by Z2. So use this, calculate S2 value. S1 is 400 into Z1. What is Z1? 9.9 divided by Z2 is 11. Calculate how much it is. S2 is how much? 360. 360 kVA. This is the value of load shared by second transformer. In the same way, calculate load shared by third transformer. With respect to 1, we are calculating. Why with respect to 1? 1 is reaches full load. At that time, how much second is supplying? How much third is supplying? Therefore, S3 by S1 equal to Z1 by Z3. Calculate S3 now. S1 is 400K into Z1 is 9.9 and Z3 is 13.2. Calculate this. How much? Yes, 300. This is 300 kVA. Therefore, we have S1. Whenever S1 is sharing 400, at that time, how much S2 is sharing? 360. And S3 is sharing 300. Now add all these three. Add the sum. Therefore, total 400 plus 360 plus 300. What is the total? 1060 kVA. So this is the maximum load they can share without overloading any one transformer. 1060, option C. Suppose if you add 1100 load, what happened? Suppose 1060 connected. Now load increases 1100. Now what happened? Definitely transformer 1 will be overloaded. That should not happen according to given question. That's why without overloading this much only it can supply. Total 3 transformers can supply 1060 kVA. Clear? So based on the short circuit data, we calculated impedance first. You should know this impedance calculation. Otherwise, you cannot solve this question. And based on the observation of impedance values, we confirm that transformer 1 will reach full load first because low impedance it is. So we taken 400 directly. And we calculated remaining S2, S3 from S1. That's it. Yes, lowest impedance directly. Any number of transformers they given, you choose lowest impedance first and then convert all other. For 4 transformers or 10 transformers or 100 transformers, same procedure. Okay. And this 49, I am leaving to you only. This is voltage regulation, V2 calculation here. Secondary terminal voltage. So I'm leaving to you only it is. So you try that question. So we are moving to next topic, auto transformers. So when transformer 1 will be overloaded, suppose 1060 we got. Now you connect 1100 kV load. What happened now? For 1100, all three will share again. Then at 1100 kVA, transformer 1 definitely more than 400 it has to share. Okay. Next, last topic in transformers is auto transformers. Auto transformer. So I can say, as previously also I said, some topics are important, no? Like losses calculation, iron loss questions are important for GATE or any examination. Like that, for any examination, one of the most important is auto transformer. Definitely one question we can expect from auto transformer also. That much important it is. And these questions are very easy. So there is some models here. Only calculation of that voltage rating, volt ampere rating, mostly we will get questions for any examination. In engineering services, 100% question will be there. GATE, mostly 90% we can expect a question every year. Okay, important it is. Auto transformers. Anyhow, I will upload that PDF today itself. You can watch it. Okay. See now. See, auto transformers. So up to now we have seen two winding transformer. Up to now we have seen only about two winding transformers like this. Now in two winding transformer and this auto transformer, there is a main important difference. Observe this. Up to now we have seen two winding transformers. Primary winding is isolated, secondary winding isolated. This is two winding case. But in auto transformer, we don't have two windings like this. Only one winding we have. Two windings separately we don't have like this in two winding transformer. We will have only one winding. In that some part of winding we will utilize as secondary side. Some part of winding. Okay, first observe the figure like this. So there are some advantages of this auto transformer, at the same time some disadvantage. That's why most of the cases what we are using practically two winding transformers only, because they are safe. Two winding transformer is safe, but auto transformer may cause some dangers. That's why we don't prefer auto transformer mostly to supply domestic loads. Why it is, I will give in the disadvantage. Observe, here we have only one winding, and shape of core also not like this square core and all this, only one type of limb. You can consider one complete limb it is. Okay, now a rectangular shape is taken here, and this auto transformer core also toroidal shapes also we have. Toroidal in your labs, particularly in your labs, those who operated auto transformer variac, so we will rotate the knob for variable voltage. That is a toroidal core, circular core, no, that is. Okay, but we are taking in the diagram like this. Same operation, whatever the core, observe. In this total winding, I will choose some part of winding as a secondary winding. So I will tap here. Tapping point it is. This is tapping point. So by tapping secondary side, I taken some voltage. Let this is the voltage V2, and let this is the primary voltage V1. Okay, and total turns. With respect to primary side, if you see this total turns, we call N1. And with respect to secondary side, if you see this total turns, we take N2. With respect to secondary, number of turns N2 here, this part. Okay. And here total turns is N1, primary side. And what is the number of turns in this part of winding? N1 minus N2. Okay. N1 minus N2 it is. Clear? So we taken only one winding. In that, some part of winding is taken as secondary by tapping. This is tapping point. By tapping. So the main definition or important statement of this auto transformer is, see, in two winding transformer, how power is transferring from primary to secondary side? How we transfer? Through this magnetic path or not? Magnetically, or induction process we call that is. So power is transferred from input to output by induction. So this is induction process. But in auto transformer, power will transfer from this input to output in two ways. That is induction, and one more is conduction. Both will be there in this, induction and conduction. So power is transferred from primary to secondary in two ways, induction and conduction. Why induction and conduction? Induction is same thing, just like flux. Whatever flux produced, it will travel throughout the core, and because of that flux, some power will transfer to secondary. And conduction means, is there any electrical isolation between primary winding, secondary winding here in auto transformer? No, both connected. No, some part of primary winding itself taken as secondary. So that is called conduction power transfer. We don't have electrical isolation. The two windings are electrically connected. But in two winding transformer, the windings are electrically isolated, but magnetically only coupled. Magnetically connected, but electrically isolated. But in auto transformer, the two windings are electrically connected, magnetically also connected. Okay, first write definition of this. Next page I am writing. Right. In auto transformers, the power is transferred. The power is transferred from primary to secondary, from primary to secondary by induction, and also by conduction, The power is transferred from primary to secondary by induction and also by conduction. Right. In this, a part of primary winding, or simply write a part of winding is common for both primary and secondary. A part of winding is common for both primary and secondary. Make a note. In auto transformer, the two windings are both electrically and magnetically connected. Okay, but two winding transformer, how the two windings are connected? Magnetically only connected. So induction power transfer only there. But here we have two power transfers, induction power transfer and also conduction power transfer. So that we will see. Okay. Induction and conduction power transfer in auto transformer. Now let's see the previous diagram once. Observe here. Current important. So see, I am taking primary current is I1 here. Secondary current is let I2 it is. Okay, primary current I1, secondary current I2. Now, one important point question you need to answer here. Observe carefully. Observe this current I1. The current I1 is coming from backside. Now. So it will be the direction. I1 is coming from backside of the core. So it is the current direction. This is current I1, and I1. It is not I1. Up to here I1. From this node or tapping point, a current I2 is going in this direction. So what is the current in this remaining part? See, this part we called common part. Common for both sides it is. Primary side and secondary side. Common part it is. Now tell what is the magnitude of current in the common part? I1 minus I2 or I2 minus I1? Tell me this. Current in common part is dash. I1 minus I2 or I2 minus I1. Which one? Most of you, yes, mixed. Some of you saying I1 minus I2 and some of you given I2 minus I1. But observe, yes, enough, good. Observe, according to KCL, you may think directly I1 minus I2 because up to here I1 is coming and some current is going in this direction. Now you may think I1 minus I2. But here we should also consider transformer action. Observe, this is high voltage because more number of turns. Then what is the current magnitude compared to secondary? Low it is. I1 is less current. But secondary side, V2 is what? Low voltage because less number of turns. Then what will be the current rating? Whether it is auto transformer, whether it is two winding transformer, the volt ampere rating will be same on both sides. V1 I1 equal to V2 I2 only. Okay. So high voltage, low current. So I1 is low magnitude, I1 is less, I2 is high. So as I2 is high, the direction of current will change here. This is the direction of current. Okay, like this, current is flowing. This is I2 minus I1. The current in this path is I2 minus I1 because I2 is greater. That's why current is flowing like this. Okay, I2 minus I1. Clear? Current in this common part is I2 minus I1, not I1 minus I2. Because I2 is greater. Why I2 is greater? According to this transformer, volt ampere same on both sides. V2 is low value means current I2 will be high magnitude compared to I1. That's why I2 minus I1. Remember? And one more important definition for auto transformer. One more important point statement is this is regarding K, transformation ratio of auto transformer. So there is a special definition for this K in auto transformer. What is the K in two winding transformer? Transformation ratio only. What is K equation? E2 by E1 or N2 by N1 or I1 by I2. Like this we are writing. But in auto transformer, K is fixed always. What is this K value is? It is always the ratio of low voltage to high voltage. Always fixed. Low voltage to high voltage only. Whether it is primary, whether it is secondary, we don't bother about this. K is always fixed one in auto transformer. So write that definition of transformation ratio in setting. Transformation ratio. Transformation ratio. Transformation ratio K. Denoted by same K only, but it will change with respect to two winding. See, it is always defined as K equal to, it is the ratio of low voltage to the high voltage. Low voltage to the high voltage always. Simply we write LV by HV ratio it is. Here it is not like E2 by E1 or V2 by V1. Like this we don't write. Like this we don't write for auto transformers. For auto transformers, K is always LV by HV only. Remember this. So why it is, I will tell. Just write this statement. LV by HV always. And one more is, in auto transformer, there is some specific range we use this K. Tell me, in two winding transformer, is there any range for K? Have you seen that word there, range of K in two winding transformer? Never, because for example, there is 400 volt by 200 volt, two winding transformer. What is the K of this? How we write? This is E1 by E2, then secondary by primary always we write 200 by 400, that is 1 by 2. Or if there is 11 kV by 33 kV transformer, what is the K of this? 33 by 11, secondary by primary, 33 by 11 is 3. So like that, different values we have. A two winding transformer it is. But in auto transformer, we don't have that much range of K. In auto transformer, the range of K we use according to our Indian standard is 0.33 less than or equal to K less than or equal to 1. So this is the range of operation of K for auto transformers. Here only we operate. There is no other than this range. Other than this range, we don't have in auto transformer. Why it is? Observe why it is. Observe the figure for this. Tell me, from this figure, This is a tapping point. You can move the tapping point, you can change. Whenever tapping position is changing, this number of turns also change. See, when you move this tapping point here, number of turns will change, means secondary voltage will change. And if you place the tapping point at the topmost turn here, if the tapping point is here at the topmost, then what is the value of secondary voltage? V2 is equal to V1 only, no? Both are same. V2 equal to V1 directly. Then what is the value of K at that time? K means some voltage by some other voltage you should write. That may be secondary by primary or low voltage by high voltage. Then in auto transformer K, low voltage by high voltage. V2 equal to V1 means both are same. Then what is that? V2 by V1 equal to 1. So what is the maximum possibility of K in auto transformer? 1 only. 1 only possible. More than this not possible. Now minimum means, let us move this tapping point to the downward direction. Downward direction. If you move this tapping point to the downward direction like this, if Small network issue today. Okay, now is it clear for all of you? Check once. Is it for audible and visible for all? Okay, right. Okay, right. Thank you. So in auto transformer, the transformation ratio is specifically defined as what? Low voltage by high voltage ratio always. And the range of K we operate is this. Actually, you may get doubt is this. It may be 0 to 1 now. So 1 is maximum. What is the maximum of K in auto transformer? 1. Then what is the minimum of K in auto transformer? You may say 0. But 0 means what is the use of that auto transformer? Okay. 0 means it is not desirable or not preferable to operate at 0. So we always preferred to operate at a minimum value of K, and that minimum value of K is 0.33. That is the break even point of this auto transformer. And according to our Indian standard also, we follow up to 0.33 only, not below that. So why it is whenever the value of K reduces, whenever K reduce, the efficiency of this auto transformer also reduce. So that is not desirable for us. So we always preferred to operate the transformers at higher value of K, that is almost nearer to 1 we preferred. That is the best efficiency and best rating of transformer also we get auto transformer if you operate K higher value or nearly equal to 1. So we preferred always to operate auto transformers near to 1 only or higher value we prefer. Remember, if K reducing, efficiency reduce, this point I will show you in one of the question. What happened? So I said here, K reducing means efficiency reduce. How it is? We may get doubt. So this I will clear you in the problem. So in the problem, while solving, I will take with the two different values of K. There I will show two different efficiency. So efficiency will reduces. Okay. So like this, you need to identify. This is also one objective type of question. Like they will give different ratings: 132 kV by 33 kV, 132 kV by 132 kV divided by 220 kV. Like this, they will give different options. Identify which are suitable to operate as auto transformer. Which ratings are suitable to operate as auto transformer? Tell me from these four, which are suitable to operate as auto transformer? How to check? You need to check K value. K should be what? Within limit. What limit? This limit. 0.33 to 1. If K value is there, you can operate that voltage rating as auto transformer. So first one, if you check, what is the K value for this? K means LV by HV only you have to take, not secondary by primary for auto transformer. LV by HV. LV is 33 divided by 132. How much? 33 by 132. Yes, 0.25. So it is less than 0.33, not suitable. So A is not suitable. Second, this is K. Calculate K for this. 132. LV by HV means directly. LV is 132. 132 by 220. I think, yes, 0.6. 132 by 220 is 0.6. So it is in the range. So you can operate this rating as auto transformer. Suitable it is. Like that, C also suitable. Like that, D also suitable. But A is not suitable because the value of K is less than 0.33. So this type of questions you may get in the options objective. Which of the following voltage rating suitable to operate as auto transformer? So then you have to check the K is should be between 0.33 and 1. Then only it is suitable as auto transformer. But for two winding transformer, is it there anything like this? No. Any voltage rating you can use for auto transformer. Anything. There is no limit. The K value may be less than 1 or K value may be greater than 1. Any value that is. So that is advantage of two winding. But auto transformer not suitable like this. Only for some particular rating it is suitable. Okay. Next. Remember about K in auto transformer. Next one. Observe the figure one time. Now we have seen the power transferred in induction motor is by two ways. Induction power transfer, conduction power transfer. Then let's find in this figure what will be the induction power transfer, what will be the conduction power transfer. Okay, total volt ampere is what? V1 I1 or V2 I2, anything you can take, both are same. So in the total volt ampere, how much induction kVA, how much conduction kVA, that we will calculate here. Okay, right. kVA induction first, or kVA input. Tell what is the kVA input from the figure. V1 I1, input voltage, input current. kVA input V1 I1. Okay, next kVA induction. kVA induction, observe the figure. Where is induction pot here? This pot is considered as induction pot of winding. This is induction pot. Why? This winding is related to only primary side but not to secondary side. But observe the common pot. This winding related to primary side as well as secondary side. This is called conduction pot. Directly conduction it is. Primary to secondary directly power transfer by conduction process. This is the inductive pot of winding. This is conductive pot. Okay. Now kVA induction means in this inductive pot, what is voltage, current, and conduction means you can find like this. So first kVA induction, let's calculate. So for this one, easy one. First tell what is the voltage rating in this pot of winding. V1 minus V2 only now. V1 minus V2. Okay, total V1 primary side, and this is V2. Then what is this pot of winding? V1 minus V2 it is. So the voltage in this pot of winding V1 minus V2, and what is the current flowing in this pot of winding? I1. Same current will flow up to here, and at this tapping point current will divide. One is I2 and other is I2 minus I1 here. Okay, so kVA induction, voltage in the induction pot V1 minus V2, and current is I1. Okay, now let's take the relation between these two here. kVA induction, important relation it is, divided by kVA input. So divide these two, V1 minus V2 into I1 divided by V1 I1. So I1 I1 cancel. Finally 1 minus V2 by V1 will be there. And V2 by V1, what is V2 by V2 means this low voltage, V1 is high voltage. K is what from the figure? V2 by V1 only. So in this diagram you got same V2 by V1 only. Sometimes you may get V1 by V2, that depends on what? Low voltage by high voltage only. But anyhow here step down auto transformer it is, so V2 by V1 only. So K is 1 minus K. Therefore kVA induction is equal to 1 minus K times of kVA input. So one important relation. So if it is asked to find induction kVA, use this formula, kVA induction. If you know kVA input, then use this equation, you will get induction. Then how to find conduction? Once you know induction, then conduction is very easy. How? Total kVA is what? Total kVA equal to kVA induction plus kVA conduction. Okay, total, because total power transfer is what? Induction and conduction, so that both I taken. So kVA conduction is now kVA input minus kVA induction. Okay, kVA conduction equal to total input kVA minus induction kVA. Now if you substitute here, kVA induction is this equation, 1 minus K times of this. So finally you will get K into kVA input. Therefore the kVA conduction is K times of kVA input, and kVA induction is 1 minus K times of kVA input. Remember both calculations required in the numericals. Induction kVA, conduction kVA. Yes, good. So this is about definition of transformer. Okay, let's see what are the advantages and disadvantages of this auto transformer. So after this, I will give break after advantage and disadvantage. Complete this. Side heading: advantages of auto transformer. Advantages. What are the advantage? What is the main purpose of auto transformer? If you remember in the tests, previous classes, test, OC test, SC test, Sumner's test, everywhere we are using auto transformer, are also called variacities. Why we are using auto transformer? For variable voltage purpose. Because if you take our supply, that may be single phase 220 fixed voltage you will get. But if you want low voltage, how can you apply low voltage? Then definitely you require a auto transformer, because in auto transformer, by changing this variable tapping point, your voltage also can change. You can change secondary voltage here by changing tapping point. But two winding transformer, can you change voltage here? No, because there is some secondary fixed voltage. You can change how? By tapping different tapping points, you will get different voltage. But every time tapping you need to change in different difficult, now that is. But auto transformer is what? During operation itself, smoothly you can change. Best example in your lab only, variac. Slowly, if you rotate the knob, voltages will change as number of turns are varying there. So the main purpose of auto transformer, to get variable voltage. So write that point. Right. The output voltage of auto transformer, the output voltage of auto transformer is variable. Is variable. Hence, so that we write in the application, enough applications we see how we are using auto transformer. Output voltage of auto transformer variable, but two winding transformer not variable, fixed, that is. Next, second point. Now here we don't have two separate windings, only one winding. In that some part you are taking as secondary, means the amount of copper required reduces or not. No need to take two separate windings like two winding transformer, only one winding we are taking. So the amount of copper required is less compared to two winding transformers. So write that. Cost also reduce, size also reduce for auto transformer. Due to single winding, due to single winding, the copper required, the copper required is less, and also less amount of core, less amount of core material. Why? If it is only single winding, core also required less. You no need to take so much amount of core. Just as winding is less, that much amount of material, core or iron material required. That is silicon steel we are using. This is one advantage compared to two winding transformer. Okay, next. So the overall size and cost of transformer reduce, because single winding, less amount of copper, less amount of core or iron material. So overall size of transformer will reduce when compared to two winding transformer. It is for same capacities. If you consider same kVA, 10 kVA auto transformer, 10 kVA two winding transformer, which size is small? Auto transformer size is small. So write that. The size and cost of, the size and cost of auto transformer is less compared to two winding transformer. two winding transformer of same rating. Okay, next advantage. Next. So this point, whatever we will write now, we will see in the numericals how this rating increase. So kVA rating of auto transformer will be very much greater than two winding transformer. So how it is, we will see in the numerical. Write that point. kVA rating of auto transformer is greater than two winding transformers. Greater than two winding transformer. Suppose if you take same copper winding in both, same copper winding take. Suppose take some copper weight of 1 kg or some number of tons, 1000 tons in both cases. Then if you use the same amount of copper in two winding transformer and also for auto transformer, you will get very high kVA rating in auto transformer. So how it is in the example problem, we will see that point. Just take note. Next point. Next. Now tell me, what is leakage flux in auto transformer? More or less compared to two winding transformer? Definitely less. Why? Only one winding. Uh, there are two windings previously. Then while going the flux from one winding to other winding, there is some leakage. But if there is only one winding, what is the leakage flux? Very, very, very less compared to two winding transformer. So write that point. The leakage flux is less than two winding transformer. Less than two winding transformer. Next. As leakage flux is less, what is the impedance of this auto transformer? See, in every transformer previously we have seen, we have resistance for every winding, reactance, and this reactance we call leakage reactance, which depends on leakage flux. More leakage, more reactance, and if reactance increases, overall impedance also increases. But in auto transformer, what is the leakage flux? Less. So what is the reactance value? Less. Then what is impedance of auto transformer? Less. If impedance is less, what is the regulation of auto transformer? Oh, yes, previously we have seen what is the maximum regulation of two winding transformer? Percentage Z only. Like that, regulation proportional to impedance. If impedance increases, regulation also increases. But what is the impedance of auto transformer? Less, because leakage flux is less. Write that point. The voltage regulation is less than two winding transformer. Is less than two winding transformer. Okay, voltage regulation is less than two winding transformer. And what about efficiency? Definitely greater. Efficiency is greater than two winding transformer here. Right, that the efficiency of auto transformer is high. Efficiency of auto transformer is greater than two winding. Greater than two winding transformer. Okay, why efficiency is greater? Now you can say losses is less. Losses is less, but losses is not less. Both will have same losses for same amount of copper winding. If we use same copper loss, same iron loss in both. But what is the main thing in auto transformer is its kVA rating increases. That is our previous fourth point. kVA rating is very much greater. Whenever kVA rating increase, the efficiency of auto transformer also increase. So how it is, I will show you this point also in the numerical. So that's why numerical is important. We are learning theoretical, and you will see the same thing again in points in the numericals. I will show this efficiency, how it is greater for auto transformer. Okay, remember this. Next, disadvantages. Disadvantages. Tell one disadvantage from your side. Tell any one disadvantage of auto transformer. Yes, any one disadvantage. Okay, no isolation. Good. Yes, can't use for any cake. Very good. Yes, very good. Yes, right. See that. Write the point. See, first of all, in auto transformer, is there any isolation between two windings? No, there is no electrical isolation. There is no electrical isolation between the two primary and second. So first point, right? And one more is previously given the range of K is 0 to 0.33 to 1. The range of K in auto transformer we use is 0.33 to 1. This is only the desirable. But can we use for any K? No, that is the drawback of auto transformer, right? That it is not suitable. It is not suitable for all voltage ratings. For all voltage ratings. So what should be the voltage rating? Such that K value should be in this range. Then only suitable. Next, second point. Second point. This is regarding electrical isolation. So write the point first. There is no electrical isolation. Electrical isolation between two windings. Between two windings. So what is the problem of this electrical isolation? Observe now. I will show you here. I will show two cases. Two winding transformer case and auto transformer case. Observe here. See now. Suppose two winding transformer first. There is a electrical isolation between two windings. Both are not electrically connected, isolated, separated it is. So this is load. If any problem occurred, suppose load gets suddenly short circuit due to some insulation fail in that, it acting as a short circuit. So whenever it is short circuit, high current will flow in the secondary. Then there may be a damage to only secondary winding. But primary winding is safe or not? Yes, because both are not in same, electrically not connected. So there is a damage to only this winding. Only this winding may damage. And primary winding is safe. Source also safe here. But check in auto transformer. If any short circuit occurred here, a short circuit current or very high current will flow. Now same current will flow in the winding. Winding completely may damage. And not only winding, your source also damages, because source also connected there. Source means what? Alternator or generator. This generator will damage. This is the problem of electrical isolation. If there is no electrical isolation, whenever any fault occurred on load side, it will reflect to source side. If any fault occurred on load side, it will reflect to source side. But in two winding, there is a protection. That's why these two winding transformers are very important for loads. Load is safe with the two winding transformer, but not with this one. Okay. Next, one more point. Right, one more drawback. What is the magnitude of that short circuit current? Suppose I said here load gets short. If load is shorted now, this short circuit current is very, very high. But if load is shorted in two winding, whatever short circuit current is flowing, this is not that much high, little increase, that's it. Magnitude of short circuit is small current, but here very, very high. Why it is very high? Since what is the impedance of this transformer, auto transformer? Small compared to two winding. That's why whenever impedance is low for winding, currents will be very high under short circuit. Write that point also. During fault condition, the magnitude of short circuit current is very high. The magnitude of short circuit current is very high. So because of that very high current, it will damage sometimes loads because of this short circuit. But here load sometimes may be protected still because of small current. Okay. Magnitude of short circuit current is very high. Next, one more disadvantage. Fourth, we have the protection. So without protection, we are talking all this. Protection is there, so no problem for us. And still we can protect. But if any protection system fail, then we should take care of our load. No, for that we are considering all this. That's why auto transformers directly we don't supply power to load using that. Auto transformer we use for some specific application, not for supplying loads directly. Two winding transformers only we use because of safe operation. That next fourth point. See, this fourth point is regarding, observe one more example. I will two winding transformer. Let it is 400 volts. It is 200 volts. Observe carefully it is. And auto transformer I am taking. This is 400. This is 200. 200 volt. Load voltage is 200. I take low voltage. Observe now. In two winding transformer, previously load is, what is the voltage across the load? 200 volts. So load is operating safely. Now suddenly, due to some problem, the secondary winding gets open. Secondary winding gets open. Secondary winding open circuited. How much voltage will appear at load? Tell, how much voltage will appear at load? Zero. No voltage will appear because winding gets open. Winding gets open. What is the voltage across load? Zero. So is any problem to load? No problem. Just supply disconnected to load. That's it. But see the auto transformer. See auto transformer. Previously voltage across load 200 only. Now suddenly, due to some problem in this common part of winding, in the common part of winding, some open circuit occurs. Some open circuit. Now how much voltage will appear at load? Tell me now. If open circuit occurs in common part here, how much voltage will appear at load? How much voltage will appear? Yes, very good. That voltage is 400 volts. Because see, there is no connection here. Due to that, what happened? This 400 volts directly will come to load now. Source voltage directly comes to load. Now, load voltage is 400 means high voltage or not? Yes. Immediately your load damage. Immediately your load will damage. Now, is it the safety operation? No. If a open circuit occur in the common part, the primary voltage directly appears at load. Though as it is high voltage, your load will damage. So if high voltages occurs, insulations of that windings damage first. Once insulation damage, all the turns get short circuited. That is we call winding burn. Okay, write that point. If an open circuit occurs in the common part of winding, that is important, common part only. Suppose in the this inductive part, if any open occur, what is the voltage at load? Zero. Then no voltage will come, only in common part. If an open circuit occurs in the common part of winding, then primary voltage primary voltage directly appears at load. Directly appears at load, comma, if it is high voltage. If it is high voltage, the load will damage. The load will damage. Okay. If it is high voltage, definitely load will damage. But is it happening in two winding? No. If secondary winding open, what is the voltage? Zero. So load will not damage. Safe. So loads are more safe if you give supply from two winding transformer only, not auto transformer. So finally, where we use auto transformers? So write that applications. Finally, applications where we use. Yes, in our labs. Already you know that point. The auto transformers are suitable as variac. Write that. It is used as variac. Variac means variable voltage supply. As a variable voltage source, it is variac. We also called dimmer stat in the labs. It is variac or dimmer stat for variable voltage. For variable voltage purpose. In the labs we use. Next second, the same auto transformers we use for starting applications. If you remember in your lab itself, induction motor starting, three-phase auto transformers we have. Same auto transformers we use. One of the starting method for three-phase induction motor is auto transformer starting. One of the starting method. Not only for induction motor, synchronous motor, three-phase synchronous motor also you can start by auto transformer. Slowly we give voltage, not at a time. That's why limiting current, starting current we will limit. Generally induction motors will draw very high current at starting. To limit that, one of the method is this, right? For starting purpose of three-phase induction motor, three-phase induction motor and synchronous motor. Synchronous motor. For starting of these motors, you can use auto transformer. And one more is the same auto transformer used as booster. It is used as booster in AC transmission lines. In AC transmission line as a booster. Why booster we call it is generally in transmission lines from sending end to receiving end, some voltage will drop or not. Some voltage drops will be there in the lines. So much long distance they are traveling. So some drop will be there, voltage drop. To compensate that voltage drop, we can use auto transformer as booster. To boost means to increase the voltage rating in the transmission line. Like that auto transformer we are using as booster. Okay, so these are some applications, but up to now whatever we have seen, you don't get 90% for gate or ESC from this. This is just about introduction of auto transformer we have seen. After break, whatever we will see now, from here only you will get, if you get any question, 100% from that topic only, not from here. Okay, so take a break for 15 minutes only. After that, come back, we will see that topic and some questions on that. With that, complete auto transformer we complete. Take break. Take a break for 15 minutes. Come back as early possible. Yes, Manish Kumar, we can use auto transformer for multi-load. So that question also we will see now. Right, started realization of auto transformer, realization of auto transformer from two winding transformer, from two winding transformer, realization of auto transformer from two winding transformer. First of all, what it means, nothing but design. Suppose there is a two winding transformer with some rating we have. Now using that two winding transformer data or rating of that, we need to design an auto transformer. Then what will be the voltage rating, power rating of that auto transformer we need to calculate. So that we will see clearly. Now, first of all, in order to realize our same heading, you can call like design of auto transformer from two winding transformer. Both are same. Okay. Now we will consider one single phase two winding transformer. Okay. Some example we will take. Now that single phase two winding transformer, we need to convert into an auto transformer. Then how to convert two winding transformer into auto transformer? Auto transformer means single winding. Two winding transformer having the two windings separately. So suppose two windings we have. Let us connect the two windings in series. Just connect in series. That is a single winding completely. Then that is itself auto transformer. Then for that auto transformer, what will be the voltage ratings and power ratings that we need to calculate. Okay. So for all this, we will take one example, a single phase two winding transformer right here. Consider a single phase 20 kVA. So one example I will take 20 kVA, 2000 volt by 200 volt, two winding transformer, two winding transformer. Example I taken this. Now using this transformer, I need to make a auto transformer. So first the figure for this two winding transformer is like this. Primary is 2000 volt, secondary is 200 volt. Okay. Primary voltage rating 2000, secondary is 200 volts. This is 2000 and this is 200 volt. Now rating of this transformer 20 kVA. Now what is the primary current of this rated current of this I1, I2, how much? How to find I1, I2? Volt ampere rating by voltage. Calculate I1 equal to 20k by 2000. How much? 10 amperes. Substitute here. This is the rated current of this winding. And similarly find I2. 20k by 200. Then you will get 100 amperes it is. Now substitute. This is the rated current of LV winding. This is the data of two winding transformer it is. Now conduct polarity test and these are the polarities. Now we need to convert this two winding transformer into an auto transformer. So we have to convert two winding transformer into an auto transformer. So how many ways we can change? Two winding means auto transformer means for single winding. So make two windings as single winding. Then in two ways you can connect in series. How? You can connect dot dot, that is called series subtractive connection, and you can connect this dot with undot like this. Suppose this is dot here and take the secondary winding place like this, and if you connect dot dot here, subtractive polarity we call. Auto transformer we design. Now this is a series subtractive connection. And one more way is what? Let us place dot here. Suppose dot is connected with undotted. Now this is additive polarity or not? Yes. The two windings we are joining in series with additive polarity. Both are auto transformers only, but one is additive polarity, one is subtractive polarity. Now which polarity is the best? Additive polarity is the best. So why we always prefer additive polarity, that we will see now. Okay. So taken up to this first. Take up to this first. So right below this figure, right? An auto transformer can be realized. An auto transformer can be realized from two winding transformer in two ways. In two ways. Like first one is series additive connection. Series additive connection. Second, series subtractive connection. Series subtractive connection. In two ways we can realize or we can design in two ways. One is additive connection, one is subtractive connection. Okay, let's see first additive connection. Right, series additive connection. First one, series additive connection. Series additive connection. So if you want series additive, how to join the two windings? Primary of these two windings, 2000 volt and 200 volt. Join dot with undot, or connect the two windings in series with opposite polarities. Simple, like this. Connecting the two windings in series with opposite polarities. Observe. So I joined two windings in series, but how to connect? Based on polarities. If it is dot, dot must be here. This is called additive connection. Dot is connected with undot of other winding. Okay. Now you will get some ratings here. What is this voltage? Let 2000 volt winding it is. This is 2000 volt and this is 200 volt. Both connected in series. Now totally how much voltage you will get on secondary side? How much voltage? This 2000 plus 200. You will get total 2200 volts. Total 2200. So like this voltage rating we got. Like that we have some other questions. So write all the questions here side by first question. So write all the questions side by same questions again you have to answer for subtractive connection. Whatever we will see the questions, almost same questions will be there in GATE ESE also. Right. First question. The voltage rating of auto transformer. The voltage rating is dash. This is first. Voltage rating is dash. These are all for auto transformer. We are ready. Second question. First question is the voltage rating is dash. Second question, the secondary current I2 is dash. Secondary current I2 is dash. Third, kVA rating of auto transformer is dash. kVA rating of auto transformer is dash. Next, fourth question. kVA rating of auto transformer is dash. Next, fourth question. Primary current of auto transformer is dash. Primary current of auto transformer is dash. Next, fifth question. Fifth one. The current in common part of winding. The current in common part of winding is dash. Current in common part of winding is dash. Sixth question. What is the induction kVA? And what is the conduction kVA? What is induction kVA and conduction kVA? So these are the questions. Same questions again we will see in subtractive connection. Then finally you will get high rating for additive connection only. Now directly voltage rating we have anyhow. Why? Additive. 2000 plus 200 additive. 2200. Now tell what is the voltage rating of auto transformer? 2000 by 2200 or 2200 by 2000. Voltage rating is always primary voltage by secondary voltage. So 2000 by 2200. This is the voltage rating of auto transformer. Don't say secondary by primary. Always primary by secondary is the voltage rating for any transformer. Next, secondary current is dash. Secondary means this one, I2. I2. This I2 we need to calculate. This is I1, primary current of auto transformer. Now there is some current in common pot. This common pot current you will get only when you know I1 and I2. So how to find this I2? So remember, whenever they ask any current, I1 or I2, anything in the question, what you need to check is, observe this I2 now. This current I2 flowing in which part of these windings here? In 200 volt winding, there is I2. Okay. Now what you have to do is go to previous. In this 200 volt winding, what is the current, rated current flowing according to this given data? 100 we got. Now same 100 amps current you have to take. You have to take in the auto transformer also same current 100 ampere. Okay, you should take 100 only, not other than this. Why? Same winding you are reconnecting as auto transformer. So whatever rated current it is designed here, same currents should flow in these windings also. Otherwise, same winding, if you take different, suppose if you take more than 100, this winding will damage. Okay. Now whatever the load you will connect here now, suppose this is auto transformer load. Whatever load we need to connect, that load is our responsibility. So we need to connect. How much to be connected? Such that load should draw maximum 100 or full load 100 amps only. Like that we have to choose the load here. Okay. Otherwise, if you connect whatever the load, if it is heavy load, then if current is more than 100, these windings will damage. Whatever two winding current is there, same current here. Okay. So what is the secondary current of auto transformer? 100 amperes. Clear? Secondary current we got. Now kVA rating of auto transformer. Third question. Now you have the secondary voltage. You have the secondary current. Once you know secondary voltage and current, you can use that product. Therefore, kVA rating is V2I2. Calculate this. This will be 2200 into 100. You will get 220 kV. 220. This much is the kVA rating. Now observe here, important observation. If it is a two winding transformer, for same winding, how much kVA is there? Only 20 is there. Now this winding is reconnected to auto transformer like this. Same winding. Then how much kVA rating you got? 220. So very much greater than the two winding transformer or not? Yes. That is one advantage of auto transformer we have seen. kVA rating is very high for auto transformer. This is the reason. Okay. Next, primary current is dash. Primary current means, again, don't go here. I1 is 10 ampere. Don't write 10 amperes. That is wrong. Primary current of auto transformer means, you observe the figure here first. This is I1. This is I1. This I1, is it flowing in 2000 volt winding only? No, this I1 is not for 2000 volt. See, previous case, I1 means in the 2000 volt winding. But here I1 means combination of two windings it is. So how to find I1? Already you have kVA rating, no? Use the same kVA rating to get I1, because kVA rating same on both the sides. So directly I1 equal to kVA rating is 220 into 10 cube divided by primary voltage 2000. Calculate 110 amperes. So this is our primary current. Okay. The I1 is how much? 110 amperes. I1 is 110 amperes. Okay. The primary current is 110 amps. Next question. The current in common part of winding is dash. Common part means this one. Now apply KCL at this node. 110 amps is in this direction. Now 100 amps is their secondary current. So I2 is this 100 ampere. Therefore, if you apply KCL, 110 is coming, 100 is going in this direction. Then what should be the current in other part? The current in common part is downward direction. In this direction, 10 ampere. Now verify here. In 200 volt winding and 2000 volt winding, currents are same as it is two winding transformer or not? I1 10 here. that is in 2000, and 200 current is 200 volt winding current is 100. Same currents will be there here also. Same currents. Like that, we have to design auto transformer. You should not take whatever the currents you want in auto transformers. If you design from two winding, whatever data is given for two winding, same utilize for auto transformer. Okay. So what is the current in common part? 10 ampere downward direction. Direction important. In previous some of the questions they asked, they given some points here. Like let this point is some A, this point is some B. They ask current here. 10 amps A to B, 10 amps B to A, like that. So direction important. 10 amps is flowing in downward direction. Okay. Don't say always it is downward, because in series subtractive next connection it will come in upward direction. Then you have to say current 10 amps in B to A direction. Okay, that you will see there. So current in common part is 10 ampere downward. Next, KVA induction. What is KVA induction? KVA induction. So for this, you can use the previous equations, whatever I given, or the other best way is KVA induction is right directly this 20 kVA. Why 20 kVA? Because previously in two winding transformer they given rating 20 kVA. Now in two winding transformer power is transferred by induction. The 20 kVA indicates induction kVA only. So directly you can write 20. Now what is the total kVA we got for auto transformer? 220. Therefore the conduction is 220 minus 20, that is 200. 200 kVA is the conduction kVA and 20 kVA is the induction kVA. Directly you can write this. That may be additive connection or subtractive connection. Directly write this. Okay. Make a note below this. Note. Make a note. Right. The losses in auto transformer. The losses in auto transformer is equal to losses in two winding transformer. Losses in two winding transformer. Both are same. Why same? Why losses are same in both? So you should know this point to find efficiency. Otherwise you cannot find. Because observe. Copper loss depends on what? Current in the winding. Iron loss depends on what? Voltage across the winding. Voltage across the winding. Now observe here. Now observe. First we will go to two winding transformer. In 2000 volt winding, how much current is flowing? 10 amperes. In 200 volt winding, how much current is flowing? 100 ampere. Now similarly in auto transformer check. In 2000 volt winding here, how much current is flowing? 10 ampere. In 200 volt winding, how much current is flowing? 100 ampere. So current same means copper loss same or not? Yes, because winding resistance same only. Same winding we placed here. Copper loss same. Okay. Now come back here. This is the voltage across this winding 2000 and here 200. So iron loss depends on voltage across the winding. Now observe in auto transformer. This is 2000 volt winding. So voltage across the winding 2000. What is voltage across this winding? 200. So voltage across the winding is same or changes? Same. This 2200 is for two windings, it is not for one winding. That is for two winding. So if you take individually, this is 200 volt here, this is 2000 volt here. So voltage across each winding remains same. Therefore, the iron and copper loss in both same or not? Yes. That's why the losses in auto transformer is same as it is two winding transformer. So remember, never forget this point. Now, I will give one important relation, derivation of only this, and remaining I don't give here because not required. Only in conventional they ask these derivations. So that derivation is regarding this kVA rating. So this KVA rating we are calculating by drawing figure and all, but directly we have one formula for this. One formula. If you know that, directly you can solve KVA rating of auto transformer without drawing all these figures. Okay. For that, I will give this formula. See the derivation. KVA rating of auto transformer. KVA rating of auto transformer. Let's see this. How? Now the same I am taking previous two winding transformer and auto transformer. Let's consider this is a two winding transformer. Let the voltage across this V1, this is V2, current here I1, current here I2. This is two winding. Now tell me in two winding transformer first. KVA rating on both the sides same or not? Whether it is two winding or auto transformer, KVA rating is same on both the sides. So I will consider with respect to secondary side in both cases. KVA rating of two winding transformer equal to V2 I2, secondary voltage, secondary current. This is for two winding transformer. Now same transformer is redesigned as auto transformer like this. Additive connection I am taking. Observe this. Dot here, additive connection. What is this voltage according to two winding? This is V1 and this is V2 according to two winding I'm writing. This is V2. Now what is this voltage totally here? V1 plus V2, additivities. Okay. Now this is our total secondary voltage of auto transformer. This is our primary voltage. This is primary current. This is secondary current I2. Okay. Now what is the KVA rating of auto transformer? Tell here. KVA rating of auto transformer with respect to secondary. So you can take either primary for both or either secondary for both cases. So I'm taking secondary. Secondary side voltage is how much? V1 plus V2 into what is the current? I2. Okay. Secondary voltage, secondary current, like two winding transformer. Secondary voltage, secondary current. Now this is for auto transformer. Now let's take the ratio of these two. Ratio. Completed this. Taking ratio of these two equations. That's it. Ratio. KVA rating of auto transformer divided by KVA rating of two winding transformer. So what is the auto transformer? We got V1 plus V2. KVA rating of auto transformer V1 plus V2 into I2 divided by second two winding transformer V2 I2 we got. Okay. Now I2 I2 cancel. Finally we have V1 by V2 or V1 plus V2 by V2. V1 plus V2 by V2. Okay, this is we got. I2 cancel. Now this V1 plus V2 by 2 we can simplify like this. Check. So this is side by I'm writing here. Check it is. See. What is the K from the previous figure? For this auto transformer, K is what? K. Low voltage by high voltage. What is low voltage here? V1 is the low voltage. V1 plus V2 is the high voltage. So low voltage is V1 by V1 plus V2. This is the K. Okay. This is K for this auto transformer. Low voltage by high voltage. Next. Let us consider what is 1 minus K. Check once. 1 minus K. What is K now? We written V1 by V1 plus V2. V1 by V1 plus V2. Now this is calculate 1 minus K equal to V1 plus V2 minus V1 is V1 cancel, V2 by V1 plus V2 So 1 minus K value is this much, V2 by V1 plus V2. Now let us take the reciprocal of this. Then you will get V1 plus V2 by V2. Therefore, this equation I will substitute here as 1 by 1 minus K. That's it. Then what is the important relation? KVA rating of auto transformer is equal to 1 by 1 minus k times of kVA rating of two winding transformer. Remember, directly you can solve this. No need to draw figure, no need to find any current. Once you know the two winding transformer kVA, just take 1 by 1 minus k. And what is k here? The k is the transformation ratio of which one? Auto transformer. K is the transformation ratio of auto transformer, because people will confuse after this. This K is for two winding or this K is for auto transformer. This is the K of auto transformer. Okay. Remember this equation. Okay. And make a note below this. This is under note only, no? Yes, this is under note. Okay, not note. KVA of auto transformer separately. This is for additive connection. This equation is for series additive connection. Use this equation for series additive connection, because for additive only we derived now. Observe, additive only it is. But if it is subtractive connection, there is slight change in the equation. That is, kVA rating of auto transformer for subtractive connection is k by 1 minus k into kVA rating of two winding transformer. So use this is for subtractive connection. This is for subtractive connection. Okay. kVA rating of auto transformer directly you can find once you know two winding transformer kVA rating. So like this type of relations, we have some important relations. So continue below this only. This is comparison between auto transformer and two winding transformer. So let's write that. Next page. Yes. So now previously I2 how we calculated in this? How I2 is calculated? I2 is flowing in 200 volt winding. So in order to know that what is the current in this 200 volt winding, you should go to previous two winding data. From that two winding only we are designing auto transformer. Now for that, in 200 volt winding, what is the current flowing here? That is we calculated. So same current you should substitute here also. That's why we taken 100 here. Now clear? Okay. So like this type of relations, some more we have right in the note. It is next page. Make a note. This is comparison between auto transformer and two winding transformer. So remember these points. So kVA rating we already written. So other are weight of copper. Weight of copper in auto transformer is equal to same. All are same relations. Only volt ampere is 1 by 1 minus k. Remaining all 1 minus k. You no need to feel difficult to remember this. Very easy. Volt ampere rating is 1 by 1 minus k. Remaining all directly 1 minus k. 1 minus k times of weight of copper in two winding transformer. So mostly in engineering services only you will get questions on these relations. For gate point of view, till now we don't have any question on this relation in gate examination. Okay, remember only for ESC prelims it may help you. Weight of copper in auto transformer, like that, per unit impedance of auto transformer is equal to 1 minus k times of per unit impedance of two winding transformer. So they will give in the question the percentage impedance of two winding transformer is some 3%. What is the percentage impedance of auto transformer? Then use this relation, you will get direct substitution. Like this, per unit voltage regulation of auto transformer is equal to 1 minus k times of per unit voltage regulation of two winding transformer. Okay, So remember these relations. These are all 1 minus k times. Only volt ampere rating will be 1 by 1 minus k. Okay. No need to confuse in any equation. Okay. First we have seen additive connection. Let's see the same questions for subtractive connection. Right. Next, series subtractive connection. Series subtractive connection. Yes, these all these relations are for same ratings. Auto transformer and two winding transformer. Suppose they given a two winding transformer of some 20 kVA. Now it is converted into auto transformer. Then what is the weight of copper in auto transformer? That is 1 minus k times of two winding transformer. Okay, so if you see numerical, you will understand. Next, second one, series subtractive connection. Series subtractive connection. Now, how to draw figure? Connect two windings in series with same polarities. Connect two windings in series with same polarities like this. Connecting the two windings in series with same polarities here. Suppose if it is dotted polarity, connect this is also dot polarity. Then how much voltage you will get on primary and secondary? This is 2000 volt winding directly. So V1 equal to 2000. This is 200 volt winding. Now as both are subtractive, no? Then what is the secondary voltage of auto transformer? How much? 2000 minus 200. 1800 volts. Secondary voltage. Like that, secondary current, primary current, current in common part. Same previous questions. Again, you should answer. Now tell me what is first one? Voltage rating. First question is voltage rating. What is voltage rating? 2000 volt by 1800 volts. Okay, 2000 by 1800. This is now step down you are getting. Input is higher than secondary. Secondary 1800 only, but primary 2000. Step down transformer it is. But previously 2000, 2200. That is a step up auto transformer. Okay, second. What is the secondary current of auto transformer? Tell me. I2. Now again you have to check where I2 is flowing. 200 volt winding. So same current, that is 100 amps only. So I2 is 100 amps only. No change. No change. Next, third, kVA rating of auto transformer. How to find? Now you have the secondary voltage, secondary current V2 I2 directly. How much? 1800 into 100. You will get 180 kVA. This is the kVA rating of auto transformer. Next, fourth question. Primary current is dash. I1. How to find I1? Once you know the kVA rating divided by voltage. 180 into 10 cube divided by 2000. Calculate, you will get 90 amps it is. I1 is 90. Next, fifth question. Fifth. What is fifth question? Current in common part of winding. Here, apply KCL now. This is 90. Here 100 ampere is there. Then what should be the current in this part? The current in this part should be in the upward direction 10 amperes. Why upward? Then only it will satisfy KCL. Otherwise it won't satisfy. 90 plus 10. Here 100. So it is satisfying. Therefore, current in common part is 10 ampere in upward direction. Or if they given any terminal names like B to A is the answer, you have to tell in the given question. So here it is upward. Next, sixth one, kVA induction, how much? I said already, write directly 20 kVA. Whatever two winding transformer is there, that is itself induction. Now what is conduction kVA? Conduction. remaining total how much? 180. In the 20 is induction. So remaining 160 is the conduction kVA. That's it. But whatever you have the questions, 99% in previous GATE ESC, all additive only. All questions are additive only. Subtractive very rarely, if they ask, we need to answer. Otherwise, all questions are additive only. Clear all of you how to calculate all these voltages? Now, if you see some numericals, then you will get still idea on all this. Direction of I2 same, direction of current will not change because observe here. If load is there now, then can you change I2 like this? Because some of you may think as dot is here, current should enter. Observe, I will show you in auto transformer also. If current enters at dot, current should leave at dot in other winding or not? Yes, same thing will also satisfy here. Check the figure. See, first one. Current enters at winding here. In one winding, current enters at dot. Now check in other winding, current is leaving the dot. Okay. Next, same as it is. Subtractive. Check here also. See, current enters at dot in 200 volt winding. Now in this 2000 volt winding, current leaving the dot. Leaving the dot. Current enters at dot in one winding is current should leave at dot in other winding. That is dot convention. Same here also it will satisfy, no doubt. But don't take this current I2 reverse, because some of you may asking here current I2 will reverse. No, I2 will not reverse because load will never supply. No, load will never supply current. We have to supply to the load. Clear? Let's see some numericals now. Yes. So whatever that relations I given, that is for additive connection only, not for subtraction. But anyhow, that per unit impedance calculation, once you know, that is for additive or subtractive, same per unit impedance and all. Okay, don't confuse. See the question. See this. Yes, Kushal. Weight of copper, how it is different? Because, oh, see, first I will tell how weight of copper is different now. Mm. Previously, for two winding transformer, how much kVA we taken? How much kVA we got? That is example we taken 20 kVA. Now in that there is some primary winding, secondary winding. So there is some weight of copper in that or not? Yes, there is some weight of copper. Now if you design the same two winding transformer as auto transformer, what is the kVA rating you got? 220 kVA for additive connection. Okay, 220. Here also copper is same, but you have to compare for 2020. That is, this is 220 now. Suppose if it is 20 kVA, or let us consider this is 20 kVA we have, and auto transformer kVA we got 220. Now for different ratings, weight of copper in auto transformer for the 220 kVA is less compared to two winding transformer of same 220 kVA or not? Tell me that point. Suppose auto transformer rating 220. There is some winding in this. You know how much winding that is. Now, if you want same 220 kVA for two winding transformer, you need to increase more copper wire in that or not? Yes. Then what is weight of copper in auto transformer? Less compared to two winding transformer of same kVA rating. Like that we have to compare how weight of copper is different. Okay. What is answer for this? Yes, a step up or step down, anything we can design by wherever. Suppose if you want step down, give the supply to low voltage side, you will get step up. Or if you want step down, give the voltage to high voltage side, you will get low voltage on other side. Same as it is two winding it is. The answer for this, yes, 550 kVA is right. 550. Given that this is the rating of two winding transformer. So draw that two winding 1000 volt by 100 volt. This is 1000, this is 100. And kVA rating of this two winding is 50 kVA. So first what you have to do is calculate the rated current of two windings I1 and I2. What is I1? 50 k by 1000. This is 50 amperes. Similarly, what is I2? I2 means in this 50k by 100. This is 500 amperes. Okay. Just we calculated rated currents. Now observe the figure. This is additive connection. Both connected in series and 1100 volts. This is the secondary current I2. We need a kVA rating of auto transformer. For that, V2 is there. And if you able to find this I2, just multiply both V2, I2, you will get kVA rating. Okay. Then I2, check I2 is flowing in 100 volt winding only or not. Yes. Now go to this transformer. In 100 volt winding, what is the current? I2 is this. In 100 volt winding, current is this 500. Now substitute here 1100 into 500. This is 550 kVA. 550 kVA. Check, two winding is only 50. How much rating increases? 500 kVA increases. Using same copper wire. Using same copper wire, you got very high kVA rate. Why kVA rating of auto transformer increases? If you get question, what is the answer? Why kVA rating of auto transformer increases? What is the reason? Simple. Because of conduction power, it increases. Conduction is there here additional. Due to that, that additional kVA here. Okay. See that weight relation, they don't give voltage ratings. Directly they will give kVA rating of two winding and auto transformer. That may be anything, additive connection or subtractive connection. With respect to kVA rating, we need to find the weight of copper. Okay, any connection that is additive or subtractive. Okay, if time is there, I will tell that how to solve. Next question. Series question. So mostly in previous gate, all questions are like this only. All questions are like this only. A 50 kVA 3300 by 230 volt single phase transformer is connected as auto transformer as shown in figure. The nominal rating of transformer, auto transformer will be dash. Nominal means here they are asking kVA rating of auto transformer is dash. So in the options all kVA, now that is kVA rating they are asking. Tell me quickly. Secondary voltage is there. Find this current I2. What is the answer? I2. See, this winding 3300 given directly. And what is this winding? 230 volt. Now in 230 volt, how much current you have to take? Let us solve from given data. In 230 volt, current I equal to 50k by 230. Calculate how much it is. Same current in two winding transformer, whatever current will flow, same you have to substitute here. How much it is? 50k by 230. It's 217.4 amperes. It is. Now substitute same current here also, 217.4 ampere. Then kVA rating equal to secondary voltage 3530 into 217.4. So you will get 767.4 kVA. Okay, check it is 767.4. Got it, all of you? This, yes, right. Next question. Next. See this question. This is also 2 marks. All are 2 marks questions only. It is a single phase 22 kVA 2200 by 220 volt two winding transformer distribution transformer is to be connected as an auto transformer to get an output voltage of 2420 volts. Its maximum kVA rating as an auto transformer is dash. Generally, when we get maximum kVA rating in auto transformer, additive connection or subtractive connection? Just now we have seen in our concept here. In the subtractive connection, we got 180. But previously in additive connection, we got 220 kVA. So where you get the maximum kVA? Additive. If they ask this type, means they are asking about additive connection kVA rating. Or if they don't mention in the question also, you have to answer for additive connection only always. Remember this. What is the answer? Yes, very good. Answer is 242 kV. See, directly you can answer it is. Without solving, directly you can answer. Observe once. Without solving, directly you can answer. If you have little concept with you, directly answer. Because two normal two winding transformer 22. If you convert into auto transformer, what is the kVA rating? Very much greater. So definitely very greater than this 22 kVA. Means not little greater. 22 is not at all correct. 24.2 also not correct because little increase, but not little. So much increase. Then there is two chances, 242 and 2420. But this much kVA will not increase. Thousands will not increase. Some 50 may become 500 like that, but not thousands of volt ampere. Therefore, only one option is possibility 242. Directly you can answer this. But if you want to answer with the actual method, you can use this equation. kVA rating of auto transformer is 1 by 1 minus k times of kVA rating of two winding transformer. Use this equation. Then what is the K of auto transformer that is required? For that, draw the figure. How much voltage, output voltage required in auto transformer? 2420 required. Means this is the connection. Additive it is. This is, I will tell one more important point. Observe here. This is 2200. This is 220. And here you will get, because of additive connection, 2420. Now I will tell one more here. Observe. The same figure like this also you may draw. 220 here, 2200 is here. To get output voltage, this is 2420. Okay, and here 220, and this is what, 2200. This is also correct because you are getting 2420 at output, but this figure is wrong. You should not take auto transformer like this. What is the reason? Yes, the reason is, if you find K of this, how much LV by HV means 220 by 2420. Definitely it is less than 0.3. This is not feasible to operate. But check here. What is the K for this? LV is this 2200 divided by 2420. This is definitely in the range. So this is accepted. If you take this second below figure, you will get wrong answer. This is not the preferred one. This is not giving maximum kVA. Maximum kVA is whenever the value of K is higher. That is also you should check in the diagram. Okay, take care of this. If we use this formula, 1 by 1 minus k, 2200 by 2420 into 2 winding transformer, 22 kVA. If you solve this, you will get 242 kVA. Or other method is what? Directly find this current I2 here, same as previous question. Multiply this voltage with current, you will get directly kVA rating. Any way you can solve, any way. Okay. Hmm. So I think maybe one of you asking. So yes, sir. I don't know who is that. So for that series subtractive connection, don't use that relation, that 1 minus k times of that. So that is not valid. Only for additive connection, you will get that kVA induction and conduction. For that, you will get other equation, just like volt ampere rating we have solved. No, volt ampere for series subtractive is what? K by 1 minus k. So like that, it will also change. So use directly induction kVA, conduction kVA directly from two winding transformer. You will get. No, grounding transformer we don't have. That you will get in protection. Next question. What is the answer? Tell quickly. Answer for this. It is advisable to use auto transformer if the transformation ratio is. What is the range of K in auto transformer first? 0.33 to 1. Okay. Now, where it is advantage or where it is preferred to operate, always higher value of K. Higher value of K. Higher value of K means higher maximum is 1. So near to 1 we always prefer. Not greater than 1 because K is not greater than 1 in auto transformer first. Yes, right. Next question. Serious question. A 2000 by 1000 by 500. So there are three windings total in this. Any number of windings you can make auto transformer. How? Just by connecting all in series. Two windings we are connecting in series as a auto transformer. So now there are three windings here. Connect three windings in series, that is the auto transformer. Or connect four windings if you have, that is also auto transformer. Now read the question. A 2000 by 1000 by 500 volt single phase three winding transformer is to be used as auto transformer with supply voltage of 3000 volt. Supply side 3000. Now there are two loads secondary side, one of 1050 kVA at 3500. So one output voltage is 3500, means add all this, you will get 3500, all additive. And other of 180 kVA at 1500 volt are to be energized from this auto transformer output. Assume the loads to have the same power factor. First question. First draw the figure. Three windings we need to connect as auto transformer. So I will take 2000 volt and 1000 volt and 500 volt. So all are additive because output voltage one is 3500. Additive only we get. Now input is how much? Input supply voltage of 3000. That's why 3000 means this is 2000, this is 1000, this is 500 volt winding. So let us take this is as input 3000 volt here, and this is secondary side. One load is at 3500 volt. One load is at 3500 volt. And what is the capacity of that load? 1050 kVA. Load kVA given. And voltage is 3500. And there is another load. See, any number of loads you can connect on the secondary of auto transformer. Okay, any number of loads you can connect. Another load is what? 180 kVA. This is at 1500. 1500 means Where we have to take 1500 here? Where we have to take? So anywhere you can take, but we need some base, no, neutral point same. Neutral is same. That's why in this 2000 volt, I will tap at one point. This is my 1500 volt. Load is here. Load KVA 180 given, and this voltage is 1500 volts. Okay. Now the question is what? First one, total current taken from supply. Supply is 3000 volts. Total current means I1 is how much? This is one question. Second question is the amount of current taken by 180 kVA load. This is 180 kVA. What is this current? They are asking this current is how much, and primary current or supply current is how much. Very easy question. Directly this I you can find first. kVA rating is there, voltage is there. So I equal to 180 into 10 cube divided by 1500. Calculate how much. Second question directly you will get how much it is. 180k divided by 1500. 120 amps, right? 120 amps. So 120 this is. So current drawn by or taken by 180 kVA load is 120 amperes. This is directly we can find. Now I1 we need to calculate. How? Current taken from supply is how much? Very easy, no need to think so much. Simply, how we are calculating previously? If you know secondary KVA, we are using same KVA for input side. Use the same thing here. Find what is the total output KVA. Calculate total output KVA. How much? This is 1 KVA, one load. This is another load. So 1050 plus 180. What is this total? 1230 kVA. If output kVA is this much, what is input kVA? Also same. Output kVA, input kVA, both are same. Power balance. Therefore, then I1 equal to 1230 into 10 cube divided by in this voltage 3000. Calculate how much? How much it is? Yes, very good. 410 amperes. This is the current taken from supply. That's it. 410. Same procedure for any number of windings in auto transformer. Two windings, same procedure. Taken output volt ampere first and then calculated primary current or input current. Same here also. Suppose there are four loads. Calculate total kVA on secondary. That is equated to primary side. Then you will get primary current. Okay. Power balance or MMF balance we call. Completed all of you? See why we are taking this 180 here, because total output kVA. This is secondary, no? To the auto transformer output side, input side. So output side we have two loads. That's why two loads kVA we added. So total output kVA is equal to input kVA. Okay. Next question. See this. Now here I will show you if K increase, I said efficiency increase. So in this question I will give the proof. Read the question first. A single phase 50 kVA 250 by 500 volt two winding transformer has efficiency of 95% at full load unity power factor. Two winding transformer, you know very well how to find efficiency using that formula. Now if it is reconfigured as 500 by 750 volt auto transformer, its efficiency at its rated load UPF will be dash. Same efficiency equation whether it is two winding transformer or auto transformer. What is the equation? Efficiency equal to x into volt ampere cos phi divided by x into volt ampere cos phi plus losses, both sum of iron and copper loss totally. So what we have to find? Efficiency of auto transformer at its rated load. Rated load means kVA. What is that kVA? We need to calculate first, then substitute here. But loss is only unknown for us. To find the efficiency of auto transformer, loss is unknown for us directly. For that, they given this two winding data. Okay, two winding transformer having efficiency of how much? 95% at full load UPF. So given efficiency of two winding transformer is 95% at full load UPF. Now using this, calculate what are the losses in two winding. That losses we will substitute in auto transformer. That's it. Because already we know what is the losses in both for the same winding data. Same iron loss is same, copper loss also same losses we substitute here. First calculate using this equation. X is full load, no? It is X is 1 into volt ampere rating of two winding, how much? 50 kVA. 50 into 10 cube. This is at UPF given, divided by 50 into 10 cube plus losses equal to 0.95 percentage. From this equation, only unknown is losses. Calculate how much? Calculate losses how much? Yes, losses are same. 2631, right? Very good. 2631 watts. These are the losses we got. Now we need to find efficiency of auto transformer. For that, its volt ampere rating is required to calculate or not? Yes. So for the given voltage rating here, what is our auto transformer rating they are giving? 500 by 750. This is 500 volts primary side. Secondary side 750 required. Actual two winding is this 250 by 500. So they taken 500 is primary side, 750 is secondary side. Means this is 500 volt, this is 250 volt, and sum of these two output is what? 750. The rating of auto transformer 500 by 750 they given. Accordingly, we have drawn figure. Okay. So for this voltage rating, calculate kVA rating of auto transformer first. Now for that, you need to find I2. This current here you need to calculate. Don't do this small mistake here. Don't do this. Listen. Don't do. What it is now this I2 as we required. Now you people will go to two winding transformer, and from this given data you will calculate I2. But if you substitute, that will be wrong. Why it is? Observe here first. This I2 in auto transformer flowing in which winding? 250. It is flowing in 250, not in 500. Up to now, whatever we have solved, all questions like we got whatever winding is there here, that is the same secondary winding of two winding transformer. But check here, 250 is on primary side here. So calculate I1 in the given two winding transformer. 50K divided by 250. How much it is? 50K divided by 250. 200 amperes. So substitute same current in this 200 amperes. Understand? Otherwise, if you find I2 now in this, that is in 500 volt, then 50K by 500, you will get 100 amperes. Then 100 amps, if you take, your answers will be wrong. You need to cross verify this I2 flowing in which winding here first. 250. That's why go to two winding transformer in 250 volt winding. Calculate current there. Substitute same current here. So 750 into 200. This is 150 kVA. 150 kVA. This is the rating of auto transformer. Now proceed to the efficiency equation. Therefore, efficiency of auto transformer, where we have to find rated load, means X equal to 1 at unity power factor. So 1 into 150 into 10 cube into 1 divided by 150 into 10 cube plus losses. Same losses whatever is there in 2631. into 100. Calculate efficiency. Calculate this. How much? Yes, 98.27, right. 98.27%. Okay. Clear all of this question, how to find efficiency in auto transformer from two winding. Same KVA rating calculation up to that same. But while calculating that KVA rating, properly observe in the figure. That's it. Now, same question, little I will modify. Try to answer. Finally, we have one conclusion there. Same question. Completed all of you? Right. Next. In the above question, right? In the above question, if the voltage rating of auto transformer, if the voltage rating of auto transformer is 250 by 750 volt, then its efficiency is dash. Then its efficiency is dash. Answer this question. Same procedure. Whatever losses we calculated, same 2631, no change. But what will change? This is the voltage rating of auto transformer. Accordingly, draw the figure. 250 is on primary side. 750 is on secondary side. 250 it is, means it is 500 volt. Then you will get 750 volt here. Additive connection. Okay. Now, what is this current I2 in this? This current I2. This is in 500 volt winding. This is in 500 volt winding. So go to two winding transformer. In 500 volt winding, what is the rated current? Calculate 50k by 500. This is 100 amperes. That 100 amps you have to take here. Now I think all of you understand this point. What current to be take here? Okay. Now what is the KVA rating of auto transformer? 750. Secondary voltage, secondary current 75 kV. Check now. KVA also reduced with this connection. KVA also reduced. Therefore, efficiency of auto transformer. Same full load unity power factor 1 into KVA rating is this much, 75 into 10 cube 1, 75 into 10 cube plus losses 2631. Same losses here also, same losses because same currents are there, same voltages for each winding, same losses. What is the answer? Tell me. Yes, 96.6. Right. Most of you did right. Good. 96.6%. So have you observed anything now? Previously, what is the efficiency? 98.27. Now what is the efficiency? 96.6%. So what you observed? Anybody observed important observation here? Very good. Yes, K value changes. What is the K in the previous K in previous? Here K, LV by HV, 500 by 750. How much it is? 2 by 3.67. Now in this question, what is the K? K here, LV by HV, 250 by 750, 1 by 3.33. So whenever K value reduces, what is the efficiency of that auto transformer? Also reduce. So which value always we have to prefer? Highest value of K we need to prefer, so that it will give high efficiency. Now clear? Write that conclusion as a note. Right. If the value of K decreases, the efficiency of auto transformer also decrease. If the value of K decreases, if the value of K decreases, The efficiency of auto transformer also decrease. Next question. Next, quickly how to do this. Next question. See this question. This question is related to three-phase auto transformer. Three-phase. So anyhow, directly in the question itself, we will see how to find numericals on three-phase auto transformer calculation. Observe. Three-phase star connected auto transformer supplies 610 HP induction motor at 0.8 power factor. The full load efficiency of motor is 88.2%. If the auto transformer having ratio of 440 volts by 500 volt, the current in the common part of auto transformer is dash. Just like our previous question, but it is a three-phase auto transformer. Which one star connected it is? See, take the figure. Three-phase auto transformer, star connected. Only one winding. There is no separate primary winding, secondary winding in three-phase also. Only one winding we take, which is star connected like this. In that, some part we will consider as secondary. Some part. He will tapping is there here. For each phase, tapping is provided. Tapping is provided. Tapping is provided. Like this. Now there is an auto transformer. An auto transformer is supplying a three-phase induction motor. A three-phase induction motor. Okay. Secondary of auto transformer is giving supply to what? That is output of auto transformer given to induction motor as input power. Now it is taking some input from here, currents. What is the secondary voltage of this given? 500 volt line voltage, say 500. And what is the primary voltage given here? 440 volts. Okay. Secondary 500 they given here, and primary 440 based on the given data line voltage rating it is. Now what we need to find? This is primary current, this is secondary current. Now we need to calculate what is the current in this common part. If you know I1 I2, that common part current easily will get by applying KCL at that node tapping point. How to find this current I2? In previous class we have one question there, same like induction motor calculation. If you find input power of motor, then you will get this current. Given 610 HP, this is the output of motor. 610 HP, nothing but output of motor it is. This is output power. Efficiency of motor is given. How much? 88.2%. Then input power easily you can find right here. Efficiency of motor equal to output power by input power. Then input we can find from this. Output is 610 HP. 1 HP is 746 watts divided by efficiency of motor 0.88 to 88.2%. Calculate input how much? How much it is? Input power of motor. 610 into 746 divided by 0.882. So this is 515941. Okay, this much watts. This is the input power of motor. Input power of motor is nothing but output of transformer only, no? Yes, both are same. Then as it is active power, what is the power equation? VI cos phi. So as it is three phase, input equal to 515941 watts. What is the formula in three phase? √3 VL IL cos phi equal to this. What is the line voltage on secondary given? Line voltage on secondary 500 volts. 500. Line current means I2 itself. current is same, and power factor also given in the question. What is the power factor? 0.8. 0.8 equal to 515941. Calculate I2 from this. Quickly calculate I2. What is I2? Oh, okay, 745, approximately 745 amperes, right? This is I2. Now we need to find I1. Once you know I2, volt ampere, secondary voltage, secondary current, and primary voltage, primary current, volt ampere. So you can use directly primary side root 3 V1 I1 is equal to secondary side root 3 V2 I2. Volt ampere is same on both the sides. So we equated this. Therefore, root 3 cancel anyhow. Primary voltage 440, primary current. Secondary voltage 500. Current I2 also we got 745. Now what is I1? I1. What is I1? 846. Okay. 846 amperes. So I1 also we got. Now substitute here. I1 is 846. I2 is 745. Now, what is the current in common pot? Apply KCL here. 846 coming in this direction. 745 going in this direction. Then what should be the current in common pot? In the upward direction, 101 ampere or approximately 100 amperes. 101. KCL is applied. Sum of, okay, 101 should be downward direction because it is 846. 745 going in this direction. Remaining 101 will be in this direction. Okay. Current in common pot is 101 or approximately in options they given 100 amperes. Clear all of you? Secondary current calculated. Then volt ampere on both the sides equated. That's it. Very good. How downward? Because apply incoming current 846. So sum of incoming current should be equal to sum of outgoing currents. So then outgoing, why we take an outgoing, it is from the node, then only it satisfies KCL, no? 846 in this direction. So in that 745 like this, 101 like this. So sum of these two is 846. Okay. So instrument transformers and all here we don't discuss. That is in instrumentation only. The particular faculty has to discuss. We don't have that is in our syllabus in transformers. That may be instrument transformer, but not here. Okay. Next question. Next. So quickly at the last we will see three winding transformer, one numerical, how to solve three winding transformer problems. So first complete this. An ideal transformer with a number of turns of various sections. AB 100, CB 60, and DB 80. Actually, the question is not here properly mentioned. AB is the complete winding. Ideal transformer having some number of turns. See, like this. There is some number of turns here. In that section, AB it is total. This is point A. This is point B. Total AB how many turns? 100 turns are there. In that, CB is taken as 60. This is B fixed. Now CB means, let us take this is C. 60 turns here. Between C and B, 60 turns. Next, DB. This is D. This is B. 80 turns. Between DB, 80 turns. This is one load you can connect. Here one load you can connect. Okay, like this. Observe, current drawn from supply I1 we need to calculate, and power factor when the supply voltage is 400 volts, and load resistance across BC there is some load resistance, that value of R is 20 ohms, and across BD the load resistance is 60 ohms. Resistance load is connected, R equal to 60 ohms. Okay, any number of loads you can connect here, 2 loads, 3 loads, any number, but they given 2 loads like this. But if you read directly, you cannot understand. You will feel that AB is 100, again from BC 60, again from BD, like that you can take. But that is wrong. It is not properly mentioned clearly here. That's why I given directly. Total AB 100. In that BC 60 tons. In that DB 80 tons. Okay. Now total how much voltage is applied to primary side? Total 100 tons on primary. 400 volts is applied to 100 tons. 400 volts is applied to 100 tons. Then what is voltage per ton? Voltage per ton how much? 400 by total tons are 100. Nothing but 4 volts. Voltage per ton is same on primary, secondary, anywhere, that is that given that we are getting 4. So what is this voltage, tell me now? And what is this voltage, tell me? 60 tons here. 60 tons. 1 ton 4. 60 tons means 60 into 4. 240 volts. And 80 tons here. Then what is the voltage? 80 into 4. 8 force is 32. That is 320 volts. Okay. What we need to find totally? This primary current and power factor. So anyhow, what is the loads connected? Resistive. So UPF only correct out of these two. So these two you can strike out. UPF only the answer, because ideal transformer, if load is UPF, primary also UPF. So we need to find current I1 mainly here. How to find current I1? If you know the volt ampere rating divided by this voltage will give this primary current. How to find that volt ampere? Now there is a voltage resistance for each load. Calculate what is the current here. Let I1, not I1, let I2 it is, and let it is I3. What is current I2? I2 voltage by resistance, 240 by 20. This is 12 amperes. Similarly, what is current I3? 320. Voltage is 320. Voltage by resistance, V by R, direct formula, 60. How much it is? 320 by 60. 320 by 60. 5.33. Okay. Now current, there is a current 5.33, and here current is 12 amperes. So current is there, voltage rating is there. Current is there, voltage rating is there. Therefore, total output KVA calculate. KVA rating. What is this KVA rating? First one. What is the KVA for second load here? This load, 20 ohms load. 240 into 12. How much? 240 into 12. 2880 volt ampere. Okay. For the next other load, similarly calculate what is the volt ampere rating of this VA rating. 320 into 5.33. Calculate how much? 320 into 5.33. 1705.6. So what is total output? 2880 plus 1705.6. So add these two. 2880 plus 1705.6. This is 4585.6 volt ampere. This is the output KVA. Now what is input KVA of transformer? Same. Therefore I1 equal to 4585.6 divided by 400 volts. Calculate how much? 400, 11.46 amperes. Okay, this is the primary current. Same procedure for every question. Total output volt ampere is equal to input volt ampere divided by that voltage will give the primary current. That's it. 11.46. Got it, all of you? This? Yes, all of you did already. Good. So all of you clear what we did? They given load resistance. So we calculated current first. Then volt ampere rating for each one. Then total added. That is equated to input side. Okay. Next. Next question. Now see this question. 3-winding transformer. 3-winding transformers. How to solve? Not only 3-winding, they given n number of windings. Whatever we will proceed now, same procedure for all. Okay. Read the question one time. A 3-winding transformer is connected to an AC voltage source as shown in figure. The number of turns are as follows. N1 is 100 turns, N2 is 50 turns, N3 is also 50 turns. Okay. And the currents in 2 windings are I2 given. I2 is 2 at an angle 30 degree and I3 is 2 at an angle 150 degree. Some magnitude of currents they given. Now we have to find what is the value of I1. This primary current I1 we need to calculate. Simple one. That primary current we need to calculate. Try this. How to find for any number of windings? So when there are n number of windings, only the formula you have to follow is either power balance, use the power balance equation, or MMF balance equation. MMF balance equation. Anything you can use. Either power balance. Power balance means volt ampere. Total input volt ampere is equal to total output volt ampere. What is that? Primary side. Suppose if there is some voltage V1 now, then V1 I1 at an angle plus or minus 5. Input volt ampere is equal to, now output side we have 2 windings, secondary, tertiary. So secondary voltage V2 I2 at an angle plus or minus 5 plus tertiary V3 I3 at an angle plus or minus 5. So what is that plus or minus 5 means? Power factor angles. Take plus for leading power factor, take minus if they given lagging power factor. But directly angles they given here, so we no need to confuse. This is power balance. Same equation MMF balance means in place of that voltage just N1 I1 at an angle plus or minus 5, N2 I2 at an angle plus or minus 5 plus N3 I3 at an angle plus or minus 5. Okay, here they given number of turns directly, so utilize this MMF balance. Any one you can use out of this, any one you can use. So we need I1, so all values are directly there. Substitute 100 I1 at 100 I1 at an angle plus or minus 5. This I1 we need to calculate. N2 I2, N2 is there 50, I2 also there 2 at an angle 30 plus N3 there 50, I3 also there 2 at an angle 150. Now if you solve 50 is outside, then this is 100, this is also 100, 100 gets cancelled. I1 at an angle plus or minus 5 equal to this is 1 at an angle 30 plus this is also 1 at an angle 150. So if you solve this, you will get the current. How to solve? Some people lost how to solve without calculator, polar form. So you can write like this, no? Cos 30 plus j sin 30. A at an angle theta. What is the formula? A at an angle theta means what? In polar rectangular form, how can we write? A cos theta plus j a sin theta. So same as it is, expand this, plus cos 150 plus j sin 150. Now that values you can solve. Cos 30, how much? Root 3 by 2. Sin 30, 1 by 2. Like that, expand this is also. Finally, you will get some value here. Solve this. You will get one value, I1 equal to 1 at an angle 90 you will get. This is the answer. Solve these values. Cos 30 plus j sin 30 plus cos 150 means you can write cos 90 plus 60. What is cos 90 plus 60? Minus sin 60. Like that, sin 150 you can write sin of 90 plus 60. Sin 90 plus theta is what? Cos 60 directly. So solve like that, you will get final value is this, 1 at an angle 90. So answer is 1 at an angle 90. This is for 2 marks. Okay. Next, last question. Last question. See this. A 200 by 100 volt 50 hertz transformer is rated at 20 kVA. Its windings are reconnected as auto transformer of rating 200 by 600. 200 on primary, 600 on secondary. 200 volt, 600 volt. Okay, this is 400 volt. Additive connection. A resistive load of 12 ohms. Resistive load RL equal to 12 ohms connected to the high voltage side of auto transformer. The value of equivalent load resistance as seen from low voltage side. So just like in two winding transformer, we are transferring secondary resistance to primary like that. Then if you transfer this load resistance to LV side, this is HV side, no, secondary side. If you transfer this is to LV side, what is its value? So don't use that formulas directly here. Don't use that divided by k square. Don't use that formulas directly. So how to solve is, first there is a voltage, there is a resistance. Calculate the current here first, I2. Calculate I2. What is I2? Voltage by resistance. 600 by 12. How much? 50. Okay. Now kVA rating of auto transformer. 600 into 50 equal to 3 kVA. Now this is same for both primary and secondary. Then try to find I1. I1 equal to 3 kVA, 3 into 10 cube divided by 200. How much it is? 300 by 2, 150 amps, no? 150 or 15? Yes. 15. Yes, 15 amps. This is I1. So I1 we got 15. Then how to find resistance component with respect to LV side? Nothing but RL dash equal to this voltage by this current. 200 by 15. How much it is? Voltage by current. So whatever here is there, load resistance, if you refer it is to LV side, same value, voltage by current, if you calculate same value of load resistance, you will get how much it is? 200 by 15, 13.33. Yes, 13.33 ohms. This is the value of load resistance when you refer to LV side. Okay. So with respect to that given load resistance, current we calculated 50 amps. Then kVA rating. Same accordingly, I1 we calculated. Then if you take that voltage by current ratio, you will get the corresponding load resistance value here. Okay, 13.33. So with this, as much as possible, we completed the number of numericals, the different models, and almost all topics. And only the thing left is your re-preparation now. So don't be away for any subject for long time. So maybe now it is completed. Now from next day, suppose tomorrow, maybe you have some other subjects started. Then what you people will do generally? So whatever is over, that is you will keep aside. And whatever is going on, that you will be always looking. But if you keep away any subject for at least 1 week or 10 days also, after opening 10 days again, it will become again new one to you. Like that, if you keep for 1 month or 2 months, because so much time is there for gate examination, and in between so much syllabus to be completed. So for that, I already said that once any subject is completed, don't keep away that subject for long time. So be in touch with every subject. Whatever is going on, that is going on. But still, in the remaining daytime or whenever you are free, try to open the previous subjects, each and every notes. Just open and flip the papers. Enough. If you don't have time, with eye contact also we can regain some concept with eye contact. So like that, if there is time, try to prepare completely, or if there is still time, try to solve some questions from standard books. But don't waste time by spending your valuable time only in the YouTubes. That is completely waste. So don't work more on YouTubes, because most of the students now asking, they are so much data is available in YouTube, they will keep on fetching for that. Finally everything they will lose. Not required. Whatever is you learn, that is enough. Okay. So with this, we complete transformer, one of the topic in electrical machines. Okay. That you will see in rotating machines. What is that? It is 30. Yes, yes, 30 kVA. It is 30 kVA means then it will change. 30 kVA. Yes, 30 kVA. No, I1 is what? No, 30 kVA divided by 200. 150 amperes. I1 is 150. Then what is the RL dash? It will also change. RL dash 200 by 150. Then how much it is? 200 by 150. Yes, good observation. 1.33 ohms. Okay, all of you clear now? 1.33. Yes, right. Concentration very important. So whatever I am saying, if you also follow, you have to do your calculation. Maybe sometime I am maybe wrong. Yes, very good. What? Yes, thank you all of you. So anonymous attendee, what is your name? Still you did not say. KVA. So yes, yes. Okay. So each and everyone sitting for long time with patience also very important. So most of you like that only. So need to appreciate your response also. Very good. Okay, we'll see that. Yes, short notes is necessary. Prepare your own short notes when you prepared, when your revision is taking place. So try to prepare your own short notes. One problem, you take equal losses. What is that? Equal losses, because in two winding transformer, auto transformer, losses is same, no? I think that's why we taken. So no need, if you get any doubt, you just message me, I will tell you. Okay, thank you, Shruti. We'll see. And those who are particularly in second year, you people may take little more time to understand, because already some people third year or fourth years means third years means almost machines will be completed up to first semester, I think. Then they will have some idea on machines, so they can understand easily when compared to the people who are right now in second year. So what you people will do is try to, if you have any doubt at any topic, try to watch the recorded videos one more time. Okay, then you will get some more clarity on each topics. Okay, let's see some doubts.
Good evening, sir. Sir,
Yeah, tell Amit.
what is the most prominent similarity and difference between induction motor and transformer?
Frequency, operating frequency is a main difference, no? Variable frequency and constant frequency, and that is electromagnetic, this is electromechanical induction motor.
Okay, sir. Thank you, sir.
Next, tell me.
Hello, sir.
Yeah.
Sir, the iron losses also depends on the area occupied by the core, no, sir. Then how
Yeah,
the
because mainly that is there, almost iron loss mainly depends on what, according to our electrical quantities, voltage, no?
yes, sir.
We are operating at same voltage for the respective windings also. That's
Okay,
why we take it. Maybe with respect to that, if you reduce iron volume, little iron loss will change. But we are talking about only electrical quantities here.
okay, sir.
Okay, right.
గుడ్ ఈవినింగ్ సార్.
Yeah, tell Rameshwari.
సార్ ఆటో ట్రాన్స్ఫార్మర్లో మనకి కోర్ ఇంకా కాపర్ సేవ్ అవుతుంది కదా సార్, అప్పుడు లాసెస్ కొంచెం తక్కువ అవుతుంది కదా సార్.
Little losses will reduce, but we are not considering the cross sections and all here. We are considering only that electrical quantities, voltage and current consider చేస్తున్నాం.
అంటే ప్రాక్టికల్లో కూడా
Yes.
లాసెస్ సేమ్ ఉంటాయి
No,
సార్.
సేమ్ ఉండదు, కొంచెం రెడ్యూస్ అవుతాయి, ఎందుకంటే మనం ఐరన్ తగ్గిస్తున్నాం కదా,
ఎస్ సార్, అందుకే
అందుకని కొంచెం తగ్గుతాయి.
ప్రాబ్లమ్స్లో నెగ్లెక్ట్ చేసినాం సార్ అది.
ఎస్ ఎస్ ఎస్.
ఓకే సార్. సార్ చాలా బాగా చెప్పారు సార్, ట్రాన్స్ఫార్మర్ చాలా కాన్ఫిడెన్స్ వచ్చింది సార్.
థ్యాంక్ యూ అమ్మా, థ్యాంక్ యూ.
సార్ వేరే మెషిన్స్ మీరు చెప్పే ఛాన్స్ ఉందా సార్?
So that is, we don't know that we have to, some management has to decide.
ఓకే సార్, ఇఫ్ ఛాన్స్ ఉంటే మీరు డీసీ మిషన్స్కి
Okay,
రండి సార్.
sure.
థ్యాంక్ యూ వెరీ మచ్ సార్.
Okay.
Hello.
Yeah, tell me.
Sir, I am solved one of the question in the previous year paper, sir. The question
Oh.
is will be a single phase transformer of rating 25 kVA supplies 12 kilowatt load at 0.6 lag power factor.
Okay.
The additional load at unity power factor in kilowatt that may be
that what you will do is, in that type of question you have to find total active power,
okay, sir.
total reactive power.
Okay, sir.
Okay, total active power, total reactive power calculation, and then what is the, it should not cross its full load capacity, no, rated
Yes, sir.
capacity. So
Yes, sir.
what
Yes,
you
sir.
will do is take the same S value, that is equal to root of PT square plus QT
Plus,
square.
yes,
Then
sir,
solve,
reactive
you
power.
will get the active power, required active power you will get from there.
Okay, sir.
Okay, right.
Thank you, sir.
Sir, in three-phase transformer,
Tell me.
if one of the phase is overloaded, what will happen on the supply end, sir? Supply end of the transformer, it is also overloaded, or the voltage will be balanced?
No, that voltage will be which type of core you are talking? Shell or core?
In core type, sir.
Core type. One phase is overloaded, no? Then definitely the primary whatever the phase secondary overloaded, same phase will take high current. Source also
Only
overloaded.
same phases.
Same.
Okay, sir.
Unbalance will be
Yesterday
there.
you told constant flux linkage theorem. What about this in DC kick test, sir?
DC kick test?
We are applying a DC voltage for a small duration.
DC voltage we are
There-
applying, but even if you apply DC, what is the variation we are creating? Alternating like variation, no? Because switch closing and opening at same time is you are creating change in flux in that.
Sir, there won't be any residual flux in the core.
That is suppose for a long time it is open,
Okay.
then you are closing and opening, so it will change.
Sir, how to reduce hysteresis loss?
By using a ferromagnetic material, and this is about material, and to reduce the hysteresis loss, WH proportional to that ratio, na, V1 by F ratios. So based on that, if you reduce voltage, hysteresis loss you can reduce, or if you increase or reduce frequency, then also hysteresis loss will reduce. With the case 1, it is V1 by F equal to constant. So whatever we have seen, based on that you can reduce the hysteresis loss.
Okay, sir. Thank you, sir.
Okay.
Thank you very much.
Okay, thank you.
Hello, sir.
Yeah, tell me.
12F, sir. Second point.
12?
12F.
12. 12F.
11, sir. 11. This one, sir. 12F, sir. The losses in auto transformer equal to losses in two-winding transformer, sir. Once explain.
Because the previous figure, if you observe, whatever currents is flowing in two winding here, 10 amps in this winding 2000 and 200 volt 100 amps, same current kada ikkada kuda flow avutundi.
Yeah.
In auto transformer also same currents. So copper loss depends on current value. So currents are same means copper loss also same in both. And where iron loss will depend? Voltage. So manaki two winding transformer, whatever voltage is there, same voltage is appearing across each winding. Ikkada 2000, ikkada 200. Winding voltage across winding is same kada. That is across the winding voltage is same undi renditlo. So same iron loss we taken. So overall losses anedi renditlo same kada.
Yes, sir.
That's why.
Sir, another one, sir. KVA induction equals to 20 kVA, sir.
This one.
6th one, sir.
KVA induction 20 I taken. Why 20? Two winding transformer, whatever is there, that is itself induction. Otherwise you use the formula, you will get that 1 minus k times of input KVA.
Yes,
You will
sir.
get same.
Sir, yesterday flux one in order to transformers, sum of X by R ratio, sir. Flux A not equals to flux B vector diagram, sir.
Not
Phasor
flux,
diagram.
that is power factor angle. Both should have same angles. Then what is doubt in that?
Once explain, sir, phasor diagram, sir. Second one.
That is not there in this here. That is in another is there. So I will tell. So whenever X by R ratio is same, power factor angle is same, then IA IB will be in phase.
Yes,
Then what is the total load current? Whenever the currents are in phase, you can directly add it. 10 plus 10, 20 amps we got. Example we taken. But if X by R is different, angles also different, phi A, phi B. Then what is the load current at that time? Vector addition of the two, no, IA plus IB.
Yes, sir.
Then what is the IL you get? Less than 20 you will get.
IL less than 20.
That means what? If both are in phase, it is having highest load current. But if there are some different in power factor angle, what is the load current? Less than 20 means it is sharing less load.
Yes, sir.
So you want high load sharing or less load sharing? That is highest load you want or low load you want? Highest only, no, always. Transformer
sir.
should supply maximum as it is possible. That's why they should have same SBR ratio.
Yes, yes.
Okay, right.
Sir, in start connection, sir.
Hmm.
Teaser transformer and a main transformer turns ratio, why we are taking N1 by N2, sir? Generally, turns ratio N2 by N1, na, sir.
Turns ratio N1 by N2 only. Transformation ratio N2 by N1. Okay?
But generally taking voltage E2 by E1 equals to N2
That
by
is-
N1.
That is transformation ratio we are equating. E2 by E1 equal to N2 by N1. Transformation ratio only, na, it is. Turns ratio means always N1 by N2 it is.
Okay, sir.
Don't confuse.
Okay, sir.
Okay, right.
Thank you, sir.
Sir,
Sir,
31F, sir.
31.
सर ये RL dash equal to 200 by 150 क्यों लिया सर?
That voltage by current, no?
वैसे मतलब नॉर्मल ट्रांसफार्मर में रेजिस्टेंस इस तरफ लाना बोले तो लॉस शुड बी
Yes.
सेम वैसा एक रूल है ना
Same.
सर?
Use that is also you'll get. See, I2 square into RL dash should be
Yeah.
equal to I1 square into RL. Here RL, here
Dash.
RL dash. Use same, you will get answer.
This is also same, sir.
Use same, you will get answer.
But you use 200 by 150. How that's correct, sir?
That is also right. Voltage by current will give the impedance or resistance, no?
Applicable for all.
Applicable for all. Use this procedure also, you will get the same answer.
Okay, I'll try, sir. Sir, one
Right.
more, sir. आप series additive में KVA of series additive page निकालो, sir.
Page number.
Maybe 4 pages before. Series additive. 2 cases, series additive, series subtract. एक page before. Sir, yes, sir, yes, sir.
This one.
Yes, sir.
Sir,
next page, एक page आगे करो, sir. सर इधर V1 plus V2 into ये कैंसिल करे बाद में अपने को 1 by 1 minus के कैसा है सर नीचे करें?
V by?
साइड में करें ना सर एक?
ये
हाँ सर. वो
is 1 minus k I taken. What is to check? What is it? 1 minus k कितना आएगा? ये V2 by V1 plus V2 आएगा ना?
Okay sir, got it. मैं क्या लिया बोलता हूँ V1 by V2 सिर्फ V2 लिया सर.
No.
Okay. सर ये X by R रेशियो आप अभी तक एक्सप्लेन करें ना सर एक डाउट. सर अगर लोड X by R रेशियो सेम रह के लोड इम्पीडेंस अलग रहता भी वो दो करंट्स ट्रांसफार्मर.
No problem. Whatever load impedance is there, two transformers will operate at that impedance only, that power factor only.
Sir, if X by R ratio of two transformers is same है sir, so two currents lag voltage or lead voltage by same angle.
Yes, same angle.
Mostly lag only because reactance.
Okay.
So lag by same angle. The drawing है sir.
Tell me.
Then,
no problem.
Then if load is some much more angle than reference voltage. Then मतलब current का angle change होता है ना, same वैसे रहता है.
Suppose V2, IA, IB both in phase. Okay.
Yes sir.
Then load, what you are saying?
The load impedance is different sir, मतलब varying very sometimes to 0.5 plus 0.2.
Whenever load impedance vary means the load power factor also vary.
Yes sir.
So accordingly these currents also vary.
But they are vary in phase only.
Phase only, because their X by R same, they operated same power factor. Whatever load you connected, they will adjust with respect to that.
Okay. Then we can add them algebraically. Okay,
Yes.
Sir. Thank you.
Sir.
Yeah. Tell you guys.
Sir, K value is range of 0.33 to 1 కదా sir. Sir, మరి ఇంతకు ముందుకు మీరు 11 kV by 33 kV తీసుకుంటే 3 వచ్చింది కదా సార్ K.
అది 2 winding transformer కదా. 11 kV by 33 kV for two winding. I just shown example. There you will get any value of K, but in auto transformer not like this అని చెప్పించాను.
Okay, sir. Sir, delta to delta, star to star is equals to 0 degrees or 180 degrees, sir. Delta and a zigzag star is also same, sir.
0, yes, 0 or 180.
Three cases same answer, are they?
Yes, అందుకే కదా అవన్నీ ఒక ఫేజర్ గ్రూప్ లో ఇండికేట్ చేసాం. సో దీస్ 3 కనెక్షన్స్ విల్ గివ్ సేమ్ వెక్టర్ గ్రూప్.
ఓకే సార్. ఇది సర్క్యూట్ డయాగ్రామ్ చూడగానే అది క్లాక్ ఎట్లా గెస్ చేస్తున్నారు సార్, ఒకసారి అది చెప్పరా సార్?
ఏది
సర్క్యూట్ డయాగ్రామ్ డెల్టా టు డెల్టా కనెక్షన్స్ అవి ఉన్నాయి కదా సార్, దాన్ని చూడగానే క్లాక్
అది సేమ్ టెర్మినల్స్. సపోజ్ ఇన్పుట్ సైడ్ A2 B2 C2 అవుట్కమ్ source connected here and load also connected at A2 B2 C2, then same kabatti this is 0 degree connection. Suppose different aithe 180 degrees. Okay,
అంటే మీరు ఒక దాంట్లో 5 o'clock, ఒక దాంట్లో 7 o'clock అని గెస్ చేశారు కదా సార్,
అవి మనం ప్రైమరీ డెల్టా చేంజ్ చేయకుండా ప్రైమరీ డెల్టాని ఓన్లీ సెకండరీ స్టార్ మనం ఇంటర్చేంజ్ చేస్తున్నాం. ఆ టైంలోనే 5 11 అవుతుంది, 1 7 అవుతుంది. అట్లా ప్రైమరీ డెల్టా నో చేంజ్ అలానే పెట్టి ఓన్లీ సెకండరీ స్టార్ చేంజ్ చేస్తున్నప్పుడే అది. ఓకే,
ప్రైమరీ నుంచి సెకండరీకి వెళ్ళినప్పుడు చేంజ్ అవుతుంది సార్. అంటే 0 degree కనెక్షన్ అని ఇచ్చారు కదా, అందుకని. సార్ వీడియో మీరు పెడతారు కదా సార్, అప్పుడు ఎన్ని టైమ్స్ చూసుకోవచ్చు సార్?
3 times కదా, నాకు అంత ఐడియా లేదు. మేబీ 3 times అనుకుంటా, అంతే కదా?
3 times only.
Yes, 3 times you can watch. If you open video and close, maybe I think that is one time is over.
No, not like that, sir. We can open and close, then after half an hour we can again continue from that, but within some 8 or 9 hours range.
Okay, more than 12 hours means it is counted.
Like that.
Okay, good. Next.
Hello sir.
Video మీరు పంపించగలుగుతారా సార్?
Videos that is not in our hand.
Sir, but we should pause it, sir, not directly close the whole site. Just pause it and put in backdrop.
Okay, once you stop, that will be counted, I think.
Okay sir.
Okay, right.
Hello sir.
Yeah, tell Tulasi.
Sir, in 25 sir. Sir, when we want to use V2I2 cos phi or else 3 V2I2 sir, I didn't get.
ఇక్కడ మనకి వచ్చిన పవర్ వాట్స్ కదా?
అవును సార్.
వాట్స్ కాబట్టి యాక్టివ్ పవర్ కదా, అది VI cos phi. సపోజ్ వోల్ట్ ఆంపియర్ అయితే డైరెక్ట్లీ √3 VI, √3 VI. 3 ఫేజ్ కాబట్టి మనం √3 చేస్తున్నాం. అదే సింగిల్ ఫేజ్ అయితే VI cos phi.
VI cos phi. Okay. Sir, in 19F sir. సార్ ఇప్పుడు నియర్ టు 1 అన్నాం కదండి సార్, అప్పుడు 1 వచ్చినప్పుడు మనము వెయిట్ ఆఫ్ కాపర్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ ఇస్ ఈక్వల్స్ టు వెయిట్ ఆఫ్ కాపర్ ఇన్ 2 వైండింగ్ అయిపోతుంది కదా.
0 అంటే 1 - K 0 కదా అసలు అక్కడ.
అవును సార్.
అంటే దట్ మీన్స్ ఇఫ్ K increases, సపోజ్ ఈక్వేషన్ రాసుకోండి, వెయిట్ ఆఫ్ కాపర్
ఇన్
ఆటో ట్రాన్స్ఫార్మర్ ఈక్వల్ టు 1 - K times of weight in 2 winding transformer. This relation. Suppose K 0.5 అనుకో ఎగ్జాంపుల్.
అప్పుడు 0.5.
0.5 into weight of copper in 2 winding means what is it mean? In auto transformer you require 50% of weight of copper of 2 winding transformer. So K 0.6 తీసుకోండి. ఇప్పుడు ఎంత వస్తుంది? 1 - 0.6 అంటే 0.4 వస్తుంది. That means weight of copper in auto transformer 40% of weight of copper of 2 winding. అంటే మనకి ఎంత రెడ్యూస్ అయిపోయింది? 60% రెడ్యూస్ అయింది కదా. దట్ మీన్స్ ఈ K నే పర్సంటేజ్ సేవింగ్ ఆఫ్ కాపర్. ఓకే, మనం K ఎంత తీసుకుంటే అంత సేవ్ అవుతుంది. అంటే K 1 అయితే 100% సేవింగ్ మీన్స్ వాట్? 100% సేవింగ్ మీన్స్ దట్ ఈస్ నాట్ ప్రాక్టికలీ పాసిబుల్. అంటే K మనకి లిటిల్ 0.99 ఆర్ 0.95 అలానే యూజ్ చేస్తాం. 100% అంటే 0 అయిపోయింది కదా మొత్తం అసలు. ఓకే
ఓకే సార్. ఇన్ 6F సార్. The voltage regulation point, can you please explain?
వోల్టేజ్ రెగ్యులేషన్ అంటే వోల్టేజ్ డ్రాపే కదా సింపుల్.
అవును
దట్ వోల్టేజ్ డ్రాప్ దేని మీద డిపెండ్ అవుతుంది? ఇంపిడెన్స్. ఎప్పుడైతే ఇంపిడెన్స్ తగ్గిందో లీకేజ్ ఫ్లక్స్ లెస్ కదా,
లీకేజ్ ఫ్లక్స్ లెస్ అన్నప్పుడు మనకి
ఇంపిడెన్స్ కూడా లెస్.
ఓకే రియాక్టెన్స్
అదే కదా ఇంపిడెన్స్ అంటే.
ఓకే సార్.
అందుకే రెగ్యులేషన్ కూడా లెస్ ఉంటుంది.
ఓకే థ్యాంక్ యూ.
Hello, sir.
Sir, one question related to the copper saving only, sir. Sir,
Okay.
for any type of connection, that relations holds good as.
Yes, any type.
Okay. And that per unit regulation and 3 formulas you've given us, sir. Sir, वो किस basis पे दिया sir?
That is for any connection, auto transformer.
No, sir. I'm asking proof how the relation directly
means,
of 1 minus k times 1 minus k times.
However, we have that weight copper volt ampere relation, no volt ampere rating of auto transformer. This one.
That which.
So in the same way, we have to derive for this remaining also. It will take so much time, but actually not required. In GATE, you never get question on this. Only for ESC mains examination, we need the proof of all this. Okay, but directly given here.
Yes, sir.
Just इसे याद रखना बस. Okay. Yes, Sandeep. Arjun. Arjun.
101 slide.
That is in previous, no? I have to say again it is. Tell what is doubt, Sandeep?
అక్కడ S1 S2 ఫేజర్ కౌంట్ చేసుకోండి సార్. మీరు డైరెక్ట్ గా రిమూవ్ ఎలా సబ్స్ట్రాక్ట్ ఎలా చేశారు సార్?
ఏదది జస్ట్ ఓపెన్ చేస్తా ఉంది.
ప్యారలల్ ఆపరేషన్.
Wait. Page number 101. Here. Which one?
ఈ క్వశ్చన్ సార్.
There.
ఇక్కడ S1 S2 ఫేజర్ కౌంట్ చేసుకోండి సార్.
Yes, 1 is to phasor sum. Okay. Because both
ఫేజ్ వాల్యూస్ కూడా మార్చాలి సార్.
So here they are operating. See, to share a load of 1000 kVA at 0.8 lagging power factor given kada. That means here we directly taken both operating at 0.8 only, same power factor. Same power factor kabatti you can directly take, no, it is direct sum. Different power factors, if they operate, if it is mentioned, then you have to take vector addition. Same power factors kabatti no problem. Okay. Arjun.
Hello.
Tell Arjun.
Sir, in today's class 28F, sir.
See, slides I have to change. It is becoming difficult. Tell what is there. What is in that?
Sir, in that number of terms you taken at 60 and 18, oh, sir, for calculating output kVA.
Okay.
But there are remaining 20% of tons, no, sir.
Because wherever you connect, suppose 100 tons are there. 60 I taken, 80 I taken. Why have we taken there only? Because according to given question, load is connected across the 2 points only, no?
Yes, sir.
Then remaining is there, but there is no current here. Current is there from primary only, but load is nothing is connected. So whatever secondary side or output side, you need to find total kVA of the load.
Okay, sir.
That's it. And that is equated to primary side.
Okay, sir.
Yes.
Hello, sir.
Tell me.
Sir, hello, sir.
Tell me, why?
Sir, in 21 S.
Twenty.
21 S, sir.
Yes, tell me.
సార్ ఇక్కడ 500 volts పై 750 volts ఆటో ట్రాన్స్ఫార్మర్ యొక్క రేటింగ్ సార్. 500 volts అనేది ప్రైమరీ సైడ్ వైండింగ్ యొక్క వోల్టేజ్. ఇక్కడ 250 volts అనేది ఏ వైండింగ్ వోల్టేజ్ అని తీసుకుంటాం సార్ ఆటో ట్రాన్స్ఫార్మర్?
నాట్ లైక్ దట్. 500/750 అంటే ప్రైమరీ సెకండరీ వోల్టేజ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్. సో ఫస్ట్ ఆ రెండు డైరెక్ట్లీ ప్లేస్ చేసి, ఇక్కడ 500 అంటే ఓన్లీ వన్ వైండింగే కదా మనకి. అకార్డింగ్ టు గివెన్ 2 వైండింగ్ ట్రాన్స్ఫార్మర్ 500 అయితే ఉంది, అది మనం డైరెక్ట్ గా తీసుకున్నాం. అంటే ఇక్కడ ఏ పార్ట్ ఆఫ్ వైండింగ్ ఉండాలి ఇంకా రిమైనింగ్? ఆ 250 ఉంటేనే 750 వస్తుంది.
అంటే ఇప్పుడు ఇది కామన్ వైండింగ్ నేను తీసుకోం కదా సార్, జస్ట్ సెపరేట్
బేస్డ్ ఆన్ వోల్టేజ్ రేటింగ్. సపోజ్ ఇన్ ద నెక్స్ట్ క్వశ్చన్ లో మనం 250/750 కదా. ఇప్పుడు 250 మనకి ప్రైమరీ సైడ్ ఉండాలి, 750 సెకండరీ సైడ్. అంటే ఇక్కడ ఏ వైండింగ్ రావాలి? 500 ఇక్కడ రావాలి. లైక్ దట్.
సార్ ఇంకొకటి అంటే స్టార్టింగ్ క్లాస్ లో క్వశ్చన్ చెప్పారు సార్ మీరు ఈఎంఎఫ్ క్యాలిక్యులేషన్ లో. దాంట్లో ఒక స్క్వేర్ కోర్ ఉంది సార్, దాని సర్కంస్క్రైబింగ్ సర్కిల్ డయామీటర్ వచ్చి 40 సెంటీమీటర్స్ అన్నారు సార్. స్టాకింగ్ ఫ్యాక్టర్ ఇచ్చారు సార్. నెక్స్ట్ ఫ్లక్స్ డెన్సిటీ ఇచ్చారు సార్. వోల్టేజ్ ఇండ్యూస్డ్ పర్ టన్ కనుక్కోమన్నారు సార్. అక్కడ నాకు నెట్ క్రాస్ సెక్షన్ ఏరియా ఎలా కనుక్కున్నారో అర్థం అవ్వట్లేదు సార్. అంటే
ఫస్ట్ వెయిట్. అక్కడ మనకి ఇచ్చిన సర్కంస్క్రైబింగ్ సర్కిల్ వల్ల టోటల్ ఏరియా వచ్చింది గ్రాస్ కదా. ఇప్పుడు మనకి స్టాకింగ్ ఫ్యాక్టర్ ఉంది కదా క్వశ్చన్ లో. సో వాట్ ఈస్ స్టాకింగ్ ఫ్యాక్టర్ ఫార్ములా? AN/AG. సో AN దాని నుంచి వస్తుంది కదా డైరెక్ట్లీ
సార్. అప్పుడు ఏజీ అంటే టోటల్ సర్కంస్క్రైబింగ్ సర్కిల్ అంటే πa² తీసుకోవాలి కదా సార్, πr² తీసుకోవాలి కదా సార్ ఏరియా.
అంటే మన స్క్వేర్ అదే కదా మనకి. ఏరియా అంటే ఏ ఏరియా? కోర్ ఏరియా కదా తీసుకోవాలి.
కానీ క్రాస్ సెక్షన్ అంటే కోర్ ప్లస్ ఇన్సులేషన్ కదా సార్.
అదే అమ్మా, కోర్ ప్లస్ ఇన్సులేషనే. సర్కంస్క్రైబింగ్ సర్కిల్ అంటే దీని డయామీటర్ వాళ్ళు ఇచ్చారు. ఈ డయామీటర్ స్క్వేర్ కి డయామీటర్ అవుతుందా లేదా? అవి రెండు ఒకటే కదా. మనం ఆ డయామీటర్ నుంచి సైడ్ ఏ అనుకో, సైడ్ ఏ స్క్వేర్ సైడ్. సో మనం రైట్ యాంగిల్ ట్రయాంగిల్ కదా ఇది, దీనికి అప్లై చేస్తే మనకి ఏ వాల్యూ తెలిసిపోతుంది కదా.
ఇది అర్థమైంది సార్. గ్రాస్ ఏజీ వాల్యూ πa² అని ఎందుకు తీసుకోకూడదు? πr² అని ఎందుకు
మనము ఈ ఏరియా అనేది స్క్వేర్ కి క్యాలిక్యులేట్ చేస్తున్నామా సర్కిల్ కి క్యాలిక్యులేట్ చేస్తున్నామా చెప్పు? స్క్వేర్ కి కదా ఏరియా అనేది. స్క్వేర్ ఏరియా కదా మనకు కావాల్సింది. అయితే ఏ స్క్వేరే కదా స్క్వేర్ కి. సర్కిల్
అంటే
కాదు
నేను
మనకు
ఎలా
కావాల్సింది.
అనుకున్నానంటే గ్రాస్ అంటే మొత్తం ఇన్సులేషన్ ప్లస్ స్క్వేర్ కదా.
మొత్తం అదే కదా వస్తుంది. ఇప్పుడు నెట్ అనేది ఆ స్టాకింగ్ ఫ్యాక్టర్ యూజ్ చేసి క్యాలిక్యులేట్ చేస్తాం.
సార్ ఇప్పుడు ఇక్కడ స్క్వేర్ కి సర్కిల్ కి మధ్య గ్యాప్ ఉంది కదా సార్, అక్కడేనా సార్ ఇన్సులేషన్ ఉండేది?
అక్కడ కాదమ్మా, కన్ఫ్యూజ్ అవుతుంది. ఇది ఇన్సులేషన్ ఇంట్లో ఇన్సైడ్. ఓకే, ఈ సర్కంస్క్రైబింగ్ సర్కిల్ అనేది వాళ్ళు కొంచెం డిఫరెంట్ గా ఇచ్చారు అంతే. డైరెక్ట్ గా స్క్వేర్ డయామీటర్ అంటే మనం స్క్వేర్ డ్రా చేసి డైరెక్ట్ గా డయామీటర్ ఇలా పెట్టి, కాకపోతే అలా ఇవ్వకుండా దీన్ని ఇలా ఇచ్చారు, సర్కంస్క్రైబింగ్ సర్కిల్ డయామీటర్ అని. సర్కిల్ డయామీటర్ అన్నా స్క్వేర్ డయామీటర్ అన్నా ఒకటే, రెండు. ఓకే, నెక్స్ట్ అంజని. Tell anyone.
Hello, sir.
Tell me.
In three-phase transformer, sir.
Uh,
Once explain shell type, sir. Confuse.
Shell type means
5 limb core.
what is doubt in that?
అంటే అది కన్ఫ్యూజ్ అవుతుంది సార్. షెల్ టైప్ ఎయిర్ గ్యాప్
అంటే
6 అంటే ఎల్వి 6 నా సార్, టోటల్ 12 ఎల్వి.
అంటే అది ఎల్వి కాదు, మీ వైండింగ్ చూస్తున్నారా? టర్మినల్సా?
వైండింగ్ సార్.
వాట్ ఈస్ డౌట్ ఇన్ దట్? వాట్ ఈస్ డౌట్ ఇన్ దట్?
అంటే సార్ ఇక్కడ ఎల్విహెచ్పి అనేది ప్రైమరీ సైడ్ 6 ఎల్వినా సార్, 12 సార్?
టర్మినల్సా అడిగేది? నో, ఇది సపోజ్ ఈ 3 phases ని మనం ఇంటర్నల్లీ కనెక్ట్ చేసేస్తాం కదా. సపోజ్ స్టార్ అనుకో, ఈ 3 కనెక్ట్ చేస్తాం, ఇంకా మనకి 3 కదా బయటికి వస్తాయి. 3 వస్తాయి బయటికి ఎల్వి, సపోజ్ స్టార్ కనెక్షన్ అయితే. బికాజ్ ఈ త్రీ phases తీసుకొని మనం ఏం చేస్తున్నాం, ఆ కనెక్షన్ ని చూడండి, ఈ 3 షార్ట్ చేసేస్తున్నాం కదా ఇంటర్నల్ గా, ఇంకా 3 వైర్సే కదా బయటికి వచ్చేది, నాట్ 6.
ఓకే ఓకే సార్.
ఫిగర్ ఒకసారి అబ్జర్వ్ చేయండి. వినీత,
డిజైరబుల్ కండిషన్స్ లో పవర్ ఫ్యాక్టర్ సేమ్ ఉంటే మాక్సిమం లోడ్ చేయడం పాసిబుల్ అవుతుందని చెప్పారు కదా సార్. సార్ అది ఆ పవర్ ఫ్యాక్టర్స్ లోడ్ పవర్ ఫ్యాక్టర్స్ కదా సార్, మరి ట్రాన్స్ఫార్మర్స్
యాక్చువల్ గా లోడ్ పవర్ ఫ్యాక్టర్ యూపీఎఫ్ అంటాం. ఈ 2 ట్రాన్స్ఫార్మర్స్ ఆల్మోస్ట్ యూపీఎఫ్ లోనే ఆపరేట్ అవుతాయి, అది మన కాన్సెప్ట్. సపోజ్ లోడ్ 0.8 లాగింగ్ అనుకో, ఈ 2 ట్రాన్స్ఫార్మర్స్ కూడా ఆల్మోస్ట్ 0.8 లాగింగ్ లోనే 2 ఇన్ ఫేజ్ లోనే ఆపరేట్ అవుతాయి. అర్థమైందా? సపోజ్ లోడ్ 0.6 లాగింగ్ అనుకో, ఈ 2 ట్రాన్స్ఫార్మర్స్ సేమ్ ఇన్ ఫేజ్ లోనే ఉంటాయి, కానీ 0.6 దగ్గర ఆపరేట్ అవుతాయి.
ఓకే సార్. సార్ అది నెసెసరీ కండిషన్ కాదా సార్? ఇప్పుడు
డిజైరబుల్ అది సాటిస్ఫై అవ్వకపోయినా కూడా వీ కెన్ ఆపరేట్ ఇన్ ప్యారలల్. కానీ అది సాటిస్ఫై అయితే అడ్వాంటేజ్ ఏంటి? హైయెస్ట్ లోడ్ షేరింగ్ వి గెట్.
ఓకే సార్. ఇంకొకటి సార్, ఇప్పుడు ఎడిటివ్ సపరేటివ్ కనెక్షన్స్ దగ్గర వెయిట్ పర్ యూనిట్ ఇంపిడెన్స్ కి ఫార్ములాస్ ఇచ్చారు కదా సార్ మీరు. ఆ ఫార్ములాస్ ఓన్లీ ఎడిటివ్ కా సార్, సపరేటివ్ కూడా?
For any connection it is, because whatever the connection, they will give directly the per unit impedance of transformer to winding, and they will ask per unit impedance of auto transformer, then use 1 minus k times of this formula directly. అది ఏ కనెక్షన్ అయినా, ఎడిటివ్ అయినా సపరేటివ్ అయినా,
అంటే
for anything it is
రేటింగ్ చేంజ్ అయింది కదా సార్, ఫార్ములా దీనికి కూడా చేంజ్ అవుతుందేమో?
ఇది మనం అసలు దీంట్లో కే రేటింగ్స్ ఏం రావట్లేదు కదా, డైరెక్ట్ ఇంపిడెన్స్ సబ్స్టిట్యూషన్ విత్ ఒక కే వాల్యూ. ఈ కే అనేది వాళ్ళు ఇస్తారు కదా క్వశ్చన్ లో, మనం ఆ క్వశ్చన్ ని బట్టి కే క్యాలిక్యులేట్ చేయాలి, ఇచ్చిన వోల్టేజ్ రేటింగ్ ని బట్టి.
ఓకే సార్. వన్ జనరల్ డౌట్ సార్, ఇప్పుడు ఏస్ మెటీరియల్స్ కూడా చాలా బుక్స్ ఉన్నాయి కదా సార్, లైక్ ఇప్పుడు నోట్స్ తర్వాత ఏది సాల్వ్ చేయాలి సార్? లైక్ వర్క్ బుక్, టెక్స్ట్ బుక్ అలా ఉంటాయి కదా సార్.
బెటర్ గో ప్రీవియస్ క్వశ్చన్స్, సో వాట్ ఎవర్ యు ఆర్ ఏబుల్ టు సాల్వ్, అండ్ దెన్ గో టు స్టాండర్డ్ బుక్స్, అండ్ దెన్ ఇన్ బిట్వీన్ ఈ మెటీరియల్స్ లో ఉన్న అన్ని క్వశ్చన్స్ ఒకసారి చెక్ చేసుకోండి, ఆల్ మెటీరియల్స్. ఓకే, సో అక్కడ ఉన్న మెటీరియల్ క్వశ్చన్స్ లో వాట్ ఎవర్ యు ఆర్ ఏబుల్ టు సాల్వ్ చేయండి. ఇన్ కేస్ ఎక్కడైనా స్ట్రక్ అయితే జస్ట్ లీవ్ దట్, అది వదిలేసి నెక్స్ట్ క్వశ్చన్స్ కి సాల్వ్ చేసుకోండి. అంతేగాని వేర్ ఎవర్ యూ గెట్ డిఫికల్టీ, డోంట్ స్టే దేర్, బికాస్ there is no guarantee what type of questions we can expect. So అందుకే మనం as possible అయిన కాడికి సాల్వ్ చేసి రిమైనింగ్ అన్ని go to standard books.
ఓకే సార్, థ్యాంక్ యూ సో మచ్.
ఓకే, రైట్. Yes, anybody?
Hello. Good evening, sir.
Yeah, good evening. Tell.
Sir, why we use a shell core in three phase? मतलब उसमें सर वो जो फ्लक्स है वो सर फ्लैट टॉप हो जाता है ना, तो मतलब उसके बावजूद भी मतलब यूज कर रहे हैं उसे क्यों?
इसमें कोर और शेल?
शेल में सर।
हाँ, शेल में किस कनेक्शन में प्रॉब्लम है? ओनली स्टार स्टार में ना हमको प्रॉब्लम।
जी जी।
रिमेनिंग ऑल कनेक्शंस नो प्रॉब्लम। सो इफ यू वांट टू यूज, अगर स्टार स्टार शेल में भी यूज करना है, सो हमको ईएमएफ क्या होना है? ऑलवेज साइनोसॉइडल बनना है। सो ये साइनोसॉइडल बनाने के लिए इसके तरीके क्या है? न्यूट्रल ग्राउंडिंग वन मेथड, वन मेथड। अदर मेथड टर्शियरी वाइंडिंग, अदर मेथड zigzag star. So ये this methods use करके we can make EMF sinusoidal here also.
सर और भी बेनिफिट है सर इसका कोई? शेल वन
shell is best for unbalanced load conditions. Suppose unbalanced load है ना generally practically outside, so उस cases में shell ही use करना पड़ेगा, मगर star star हम use नहीं करते हैं. What connection we are using? Delta star है ना always, so no problem for us. Okay.
अरे सर वो आपने कहा था कि मतलब जैसे दो ट्रांसफार्मर है, डेल्टा डेल्टा और स्टार स्टार सेम रेटिंग के, तो कैसे देख के बताएंगे कि
ओके वो वायर थिकनेस, वायर का थिकनेस ना
सर? जैसे अब जैसे इनमें जो वायर्स आएंगी आउटपुट, मतलब जो ट्रांसफार्मर से बाहर वायर आएगी, वो उसमें तो सर वो लाइन करंट फ्लो होगा ना दोनों में?
लाइन करंट, ओके,
मतलब जो ट्रांसफार्मर से बाहर आ रही है वायर सर, दोनों में लाइन करंट होगा, तो दोनों में लाइन करंट सर सेम होगा,
सेम मैग्नीट्यूड होगा, और इसलिए यू आर आस्किंग सेम थिकनेस तो होता, सेम थिकनेस वही ना
सर? हाँ जी।
सो हियर considering only phase windings, not line wind, that direct output is, this is output na from delta and star.
Yes,
so let us consider phase winding of this and phase winding of this. So at the join delta में क्या बनता है? but see I will explain. delta में ये join है ना, गेट डेल्टा, सो ये वर्टिसेस पे जो भी हम ये दो कनेक्शन क्या होते हैं इधर जॉइंट करते हैं, सो ये जॉइंट के बाद वी विल टेक सम लिटिल मोर थिकनेस ऑफ कंडक्टर बिकॉज लाइन करंट है ना इसमें √3 टाइम्स ऑफ दैट टाइप, सो इसलिए जो भी ये फेज में वाइंडिंग है इससे भी थोड़ा ये थिकनेस बढ़ जाएगा इधर. yes according to you, by observing only outside wires you cannot say. good one. only the phase winding we should take thickness of phase winding. yes 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 good good observation.
ओके थैंक यू।
अभी क्या है, कहाँ से आप, कौन सा सेंटर?
मैं दिल्ली से सर।
ओके गुड,
थैंक यू।
नेक्स्ट अब्दुल।
सर आप एक बार सीरीज एडिटिव और सीरीज सब्ट्रैक्टिव एक बार फिर से बोलो सर, एक व्यू बोल दो सर ना, इन डेप्थ ना, एक व्यू बोल दो आप।
एडिटिव कनेक्शन मींस उसको कैसे एडिटिव बनाना है, जो दो वाइंडिंग्स को सीरीज में ही कनेक्ट करना है, मगर
नहीं सर उसके बारे में नहीं, जो वोल्टेज रेटिंग केवीए रेटिंग बताया था ना, वो कैसा करते, कैसा कैलकुलेट करते, वो थोड़ा
एक बार फिगर देखना। एडिटिव कनेक्शन एडिटिव है ना ये
जी,
इसमें सो ये 2000 वोल्ट वाइंडिंग है, ये 200, ये दो एडिटिव है ना, इसलिए डायरेक्टली सम कर दिया इधर।
अच्छा,
ये वोल्टेज रेटिंग क्या बनेगा अब, ये प्राइमरी 2000 है, सेकेंडरी 2200 वोल्टेज रेटिंग आ गया।
अच्छा,
नेक्स्ट सेकेंडरी करंट को कैलकुलेट करना। सो ये सेकेंडरी करंट एक बार चेक कर लेना, I2 किस वाइंडिंग में फ्लो कर रहा है, 200 में।
हाँ,
सो ये टू वाइंडिंग से इधर डिजाइन करते हैं ना, इसलिए टू वाइंडिंग ट्रांसफार्मर को जाने के बाद यहाँ I2 200 वोल्ट वाइंडिंग में कितना करंट फ्लो कर रहा है कैलकुलेट करना।
पहले ही,
हाँ पहले ही करके रखना इसे।
अच्छा ओके फाइन।
100 एम्प्स है ना इसमें
जी,
सो सेम 100 एम्प्स इधर भी लगा देना। सो I2 हियर आल्सो 100। ओके नेक्स्ट KVA रेटिंग, वोल्टेज करंट प्रोडक्ट।
ओके
नेक्स्ट प्राइमरी करंट। सो वंस ये KVA मालूम हो गया ना, KVA रेटिंग, देन प्राइमरी करंट इजीली यू कैन फाइंड KVA बाय वोल्टेज, दिस वन।
सर अगर 3 फेज ऑटो ट्रांसफार्मर में भी रहता सर,
same, but there KVA rating by their √3 VL IL we have to use formula.
अच्छा
KVA
नीचे
rating equal to this
ठीक,
is then
अच्छा
current I equal to divided by √3 VL.
हाँ अगर 3 फेज है तो ऐसे ही
3 phase.
कैलकुलेशन बाय
Yes,
√3
yes,
आती।
yes.
ओके फाइन। हाँ एंड करंट इन
Current in common part means KCL अप्लाई कर लेना। ये 110 amps है, ये 100 amps है। अगर KCL अप्लाई करने से इधर कितना करंट जाएगा? 10 amps जाएगा ना। 110 आ रहा है ना इसे
हाँ
इधर,
ओके फाइन। हाँ
इसमें 100 जा रहा है तो ये 100 10 amps इधर आना है, इसलिए ये 10। Next
अच्छा
KVA induction formula also we have 1 minus K times of input KVA, वो भी यूज
हाँ
कर सकते हैं।
हाँ ओके सर।
डायरेक्टली आई गिवन बिकॉज 2 वाइंडिंग में जो भी है उसे इंडक्शन ही बोलते हैं, डायरेक्टली लिख सकते हैं इधर।
अच्छा
सेम
अच्छा
आंसर ये होगा, सेम एज इट
कंडक्शन
इज।
सर।
कंडक्शन टोटल 220 है ना,
हाँ टोटल
इसमें
220।
20 इंडक्शन चलेगा, अब
अच्छा
रिमेनिंग 200 कंडक्शन।
सर हाँ और एक सर ये इंडक्शन कंडक्शन बोल रहे था ना आप, ये कैसा बोले सर ऑटो ट्रांसफार्मर में? क्योंकि तो मैं जहां तक मेरे को मालूम है मैं आपको बता रहा हूँ, वो इंडक्शन का तो जो फॉर एग्जांपल इंडक्शन मशीन ले ले तो ऑटोमेटिक पोल्स इंड्यूस होते, इसलिए अपन क्या करते का तो विदाउट गिविंग सप्लाई इंडक्शन का बोलते इंडक्शन मोटर। अगर वो डीसी मशीन्स में का तो बाय यूजिंग सम सप्लाई टू द वाइंडिंग देन द पोल्स विल बी जनरेटेड राइट, तब उसे कंडक्शन बोलते हैं। लेकिन ये ऑटो ट्रांसफर में कैसा बोलते हैं आप? इंडक्शन हुआ
एक ये 2 वाइंडिंग में पावर इनपुट से एक वाइंडिंग से अदर वाइंडिंग को कैसे ट्रांसफर हो रहा है? थ्रू फ्लक्स ही है ना,
मैग्नेटिक सर्किट।
इसे भी इसे ही इंडक्शन बोलते हैं।
हाँ
ये ही
ओके
इंडक्शन। बट ऑटो ट्रांसफार्मर में सो हाफ ऑफ द वाइंडिंग वट एवर करंट इज फ्लोइंग, इसमें फ्लक्स प्रोड्यूस होगा या नहीं होगा? होगा ना,
होगा सर।
ये सेम फ्लक्स इसमें भी जाएगा ना टोटल।
हाँ म्यूचुअल फ्लक्स करते हैं।
देन ये जो भी फ्लक्स सेकेंडरी वाइंडिंग को कट कर रहा है वो इंडक्शन पावर ट्रांसफर कर रहा है नहीं कर रहा
कर रहा सर।
है? वही इंडक्शन। एंड ये नीचे जो भी पार्ट ऑफ कॉमन पार्ट ऑफ वाइंडिंग है, ये डायरेक्टली कनेक्टेड बिटवीन प्राइमरी एंड सेकेंडरी है ना,
हाँ
दो भी इलेक्ट्रिकली
जी
कनेक्टेड ना, दो भी, इसे
हाँ
हम कंडक्शन पार्ट बोलते हैं। डायरेक्ट करंट ट्रांसफर इज देयर
अच्छा,
डायरेक्टली, ये वाइंडिंग।
इसलिए प्राइमरी का इंडक्शन बोलते हैं और नीचे का कंडक्शन बोलते हैं सर।
यस सो जो वाइंडिंग the winding which is related with only one side, that is inductive part, and the winding which is related for both sides, that is conductive part। ये नीचे का winding both sides का related है ना,
रिलेट है सर।
इसलिए कंडक्शन है।
अच्छा अच्छा सर, वो
ये
सीरीज सब्ट्रैक्टिव भी बोले तो
सीरीज वो भी सेम कैलकुलेशन है ना ऑलमोस्ट। सब्ट्रैक्टिव में
जी
डॉट
जी
डॉट कनेक्टेड मींस वोल्टेज क्या हो गया? सब्ट्रैक्शन हो गया ना, 2000 minus 200,
अच्छा
सो वोल्टेज रेटिंग। नेक्स्ट I2, अगेन I2 किसमें फ्लो कर रहा है? 200 में।
हाँ
सो सेम करंट जो कैलकुलेट किया वो ही सेम करंट आ गया।
अच्छा ओके फाइन।
एंड KVA रेटिंग ये सब सेम कॉमन।
हाँ ओके सर ओके।
वोल्टेज करंट प्रोडक्ट I1 KVA बाय वोल्टेज।
अच्छा हाँ आउटपुट केवीए रिफर्स टू
सेम।
प्राइमरी। अच्छा
देन करंट कॉमन पार्ट में KCL अप्लाई कर लेना। 90 आ रहा है, इधर 100 जा रहा है, सो इधर कितना करंट आना है? 90 plus 10 100 बनेगा।
हाँ राइट,
दैट्स व्हाई 10 amps अपवर्ड डायरेक्शन।
10 amps in upward direction।
देन ही ना तभी 100 बनेगा।
हाँ अच्छा ओके फाइन। हाँ केसीएल अप्लाई करें तो वैसा आता है।
यस,
जो इसके पहले एडिटिव में 10 amps डाउनवर्ड डायरेक्शन में था ना सर?
वो उधर अगेन अप्लाई करना करंट 110 आ रहा है ना इनपुट से, इसलिए वो 10 amps नीचे जाना है।
अच्छा केसीएल अप्लाई करें तो वैसा पता चलता।
यस
केवीए इंडक्शन सर। और एक है सर, सर आप पहले जो क्लास होते से पहले आप थोड़ा शुरू करें ना सर, क्या बोलते हैं, थोड़ा मिस हुआ था मैं।
पैरेलल ऑपरेशन
हाँ जी पहले ऑपरेशन प्रॉब्लम के सामने थोड़ा क्या बोलते थोड़ा
टू ट्रांसफार्मर्स इन पैरेलल लोड शेयरिंग।
जी वो थोड़ा इक्वेशन सा है ना सर, वो थोड़ा बोल सकते सर।
मैं PDF अपलोड करूंगा बिकॉज वो और एक पेज में जाना पड़ेगा फिर। पीडीएफ अपलोड करूंगा, एक बार चेक कर लेना अभी।
सिर्फ इक्वेशन सही है सर बोले सो आप?
हाँ,
और कुछ है
डायरेक्ट
सर?
फिगर डाल के डायरेक्ट इक्वेशन लिख दिया।
अच्छा SCA SB वैसे
हाँ,
लिख
यस
दिया
यस
सर।
भी, यस यस।
हाँ सर और एक है सर, मैं देख लेता हूँ सर वो PDF है, ठीक है, थैंक यू सर।
ओके।
सर ये डिजायरेबल कंडीशंस है थोड़ा, वो उसमें एक है ना सर, इन ऑर्डर टू शेयर लोड बेस्ड ऑन द
बेस्ड ऑन देयर
कैपेसिटी।
कैपेसिटी,
हाँ,
impedance should be inversely proportional to kVA rate.
अगर ये नहीं सेटिस्फाई हुआ तो सर?
यस, यू कैन ऑपरेट, मगर कैसे शेयर करेगा? वो बेस्ड ऑन रेटिंग पे शेयर नहीं करेगा, एक ज्यादा शेयर कर देगा, एक कम शेयर कर देगा, वो
हाँ
डिजायरेबल नहीं है ना।
हाँ, उसमें
जो
ओवरलोड होता
रेटिंग,
है।
हाँ, एक ओवरलोड बन जाएगा मे बी लाइक
जी
दैट। टू अवॉइड दैट प्रॉब्लम ये कंडीशन को अप्लाई करना।
अच्छा सर, और एक ये वोल्टेज रेटिंग एसेंशियल भी वही बोले, डिजायरेबल भी वही बोले
यस,
ना सर?
नेसेसरी वो कंडीशन तो कंपलसरी होना है। डिजायरेबल मींस क्या है, अगर थोड़ा वोल्टेज डिफरेंस है उस पे भी
हाँ,
ऑपरेट कर सकते हैं।
हिचकिचाते हो तो भी।
यस, डिजायरेबल मींस लिटिल वेरिएशन एक्सेप्टेड,
अच्छा
बट नॉट सो मच।
अच्छा अच्छा
सो
सर,
नेसेसरी आ जाएगा।
जी जी सर, ये और एक सर, ये फेज सीक्वेंस ऑफ 2-3 फेज ट्रांसफार्मर शुड बी सेम बोले थे ना सर? इट इज द
वो
नेसेसरी कंडीशन इन पैरेलल
यस
ऑपरेशन।
यस, वो क्या है, सीक्वेंस जनरेट करते हैं ना 3 फेज में, आर वाई बी करके 120 डिग्री डिस्प्लेसमेंट।
जी जी।
सो अगर ट्रांसफार्मर ये में सीक्वेंस आर वाई बी आया है, ट्रांसफार्मर बी में भी आर वाई बी ही आना है। सेम
अच्छा
सीक्वेंस, वोल्टेज सीक्वेंस आफ्टर 120 आर वाई बी। अगर ये सीक्वेंस चेंज हो गया तो अगेन सर्कुलेटिंग करंट्स आ जाएगा। सो व्हाट इज सीक्वेंस के बारे में अल्टरनेटर में पढ़ सकते हैं।
अच्छा सर मेरे हाँ जी, फॉर एग्जांपल एक ट्रांसफार्मर का आर वाई बी है सर, सेकंड ट्रांसफार्मर का आर वाई बी है, लेकिन मैं कनेक्ट किया पहले ट्रांसफार्मर आर फेज, इट हैज बीन कनेक्टेड टू बी फेज, सेकंड ट्रांसफार्मर बी फेज। नहीं ऐसा कंसिडर कर लिया सर, मैं ऐसा कंसिडर करके कुछ गलत से कनेक्शन लगा के पैरेलल ऑपरेट किया,
देन सर्कुलेटिंग करंट आ जाएगा ना।
क्यों नहीं नहीं आएगा सर, लेकिन मैं क्या बोल रहा था, तो मैं बी फेज को कनेक्ट किया ना, तब वो बी फेज 0 डिग्री जैसा कंसिडर नहीं कर सकते फेज एंगल।
जो भी एक फेज को रेफरेंस मान के चलना है।
अच्छा, जो
तो
पहला
ट्रांसफार्मर ये में
जी
आर
जी,
लिए है ना, उसमें भी आर ही लेना है।
अच्छा अच्छा सर, और एक ये जो आप 3 फेज कनेक्शन से दिए थे ना सर, डेल्टा डेल्टा स्टार स्टार डेल्टा स्टार एंड स्टार डेल्टा, राइट? उसमें मैं डेल्टा स्टार में सर, डेल्टा स्टार में DY7 और YD7, इसको मैं कनेक्ट पैरेलल ऑपरेटिंग करेंगे सोच रहा हूँ सर। ओके
Yes,
सर,
you can do.
हाँ हाँ, लेकिन उस टाइम पे फेजर डायग्राम्स कैसे रहते, थोड़ा रिप्रेजेंट करो सर पेपर में, क्योंकि तो थोड़ा गड़बड़ हो रहा था, कुछ कौन कैसा फेज डिफरेंस रहता वो थोड़ा।
नहीं, वो जो भी कनेक्शन है, जो भी सेम डिस्प्लेसमेंट है ना, DY7 है, YD7 है, ओके।
हाँ,
सो इसका डिस्प्लेसमेंट सेम मींस
सेम,
इसका सिग्नल्स कैसे स्टार्ट होता, 7 मींस 210 डिग्री है ना, ये 0 डिग्री 180, 210 मींस 30 हियर। सो ये दोनों के आर फेज यहाँ से ही स्टार्ट होते हैं। सपोज ट्रांसफार्मर DY7 है, ये YD7, इसका भी इधर ही स्टार्ट होगा एग्जैक्टली, दोनों का आर फेज। अब वाई फेज क्या होगा इनका 120 डिग्री,
इधर से आगे 120 डिग्री लैगिंग,
120 यहाँ से वाई फेज, इसे भी यहाँ से वाई फेज, सेम एज इट इज वाई फेज, ये भी वाई फेज यहाँ से। सो भी इन फेज है ना, एनी हाउ बोथ।
हाँ,
सिमिलरली बी फेज।
YD11 करे तो सर मैं नीचे का सेकंड ट्रांसफार्मर YD7 का को आप ऐसे प्रेजेंट करें।
ओके, अब YD11 मींस 30 डिग्री लीडिंग हो जाएगा ना, मींस आर फेज कहाँ से स्टार्ट होगा, यहाँ से स्टार्ट होगा 30 डिग्री लीडिंग ना, 11 मींस
हाँ
0 है, 30 डिग्री लीडिंग ले लेना। अब दो भी ड्रा करके चेक करना, ये आर फेज साइड्स पे नहीं होगा,
नहीं
डिफरेंस आ गया ना, देन सर्कुलेटिंग करंट से।
अच्छा, मैं सोच रहा हूँ कि नीचे का जो हम सेलेक्ट किए हैं YD11 का, प्रीवियस का आर फेज से 30 डिग्री पहले आता सोच रहा हूँ, वो वैसा नहीं है सर?
नहीं 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 नहीं,
अच्छा अच्छा, वो जो इनिशियल होता सो जो फेजर डायग्राम में 30 डिग्री लीडिंग के
Yes.
पास से शुरू होता।
yes 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 yes
अच्छा 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 सर, और एक है सर, ये क्या बोलते हैं, सर अभी हमें 3 फेज कनेक्शन सर डेल्टा या स्टार हमें रिप्रेजेंट करते हैं ना सर, फॉर इजी टू अंडरस्टैंड। नहीं सर, विथ वाइंडिंग्स।
okay हाँ बताना।
इसमें एज थ्योरी पॉइंट ऑफ व्यू सर मैं बोल रहा हूँ, प्रैक्टिकल
बोल।
में अगर तो जो वाइंडिंग करते हैं वो हिसाब से हमें कौन सा स्टार कौन सा डेल्टा बोल सकते हैं। थ्योरी में सर फॉर एग्जांपल हमें वाइंडिंग सा पोजीशन उधर फेसिंग उधर करे सर, ये फेस का अपन क्या कहते हैं बी की तरफ बोल रहे हैं आप, बी और सी की तरफ है वाइंडिंग, लेकिन मैं 3 फेजा का जो वाइंडिंग जो टर्न साथ फेसिंग उधर किया मैं तो उसके तरफ किया मैं, जो उस टाइम पे उसका बैक ईएमएफ और उसका जो वोल्टेज कैसे एक्सबीट होता, कौन से डायरेक्शन में एक्सबीट होता और क्या उसका
नहीं एक बार फिगर मुझे भेजना, मैं चेक करूंगा टेलीग्राम में। ऐसे समझ में नहीं आता है, फिगर को मुझे ड्रा करके भेज देना, मैं देखता हूँ।
हाँ सर और एक है जो हमें इजी टू अंडरस्टैंड करने के लिए आप ऐसा डेल्टा कनेक्ट करके इसमें ए सीक्वेंस के बाद बी सीक्वेंस, बी के बाद सी, ये ABC का बोल रहे हैं, लेकिन ऐसा नहीं रहता को बोले था फिर भी आप एक बार का तो मालूम आपको थोड़ा इन्फॉर्मेशन बोलने के लिए क्लॉकवाइज में ऐसा रहता है, एंटी क्लॉकवाइज में ऐसा, हमें वेक्टर्स ऐसा रिप्रेजेंट करते क्या को बोल रहे, लेकिन मिसाल के तो बस हकीकत में ऐसा नहीं रहता को बोले आप यार, शुरू में बोले था शायद,
क्या याद नहीं आते
जी। वो कौन से 3 फेज
इसके
का
बारे में,
कनेक्शन,
वो 3 फेज कनेक्शन में
जी 3 फेज सिंगल फेज और 3 फेज का डिफरेंस बताते भी, हाँ राइट हार्मोनिक्स के टाइम पे बोले था सर आप, हार्मोनिक्स का जो टॉपिक बोलते से टाइम पे एक मैम कौन की, आई एम सॉरी, कोई पूछे तो उस टाइम बोले था आप कनेक्शन सा हमें ऐसा रिप्रेजेंट कर रहे ABC का को, लेकिन इस तरह नहीं रहता को बोल के कुछ बोले, वो थोड़ा होश में उड़ गया था, कुछ क्या बोले सर आप आप उसका क्या बोलते हैं रिप्लाई बोले था।
मैं वो एग्जैक्ट कहाँ बोले मुझे वो बताया तो मैं बता दूंगा क्या बोला मैं उधर।
हार्मोनिक सर पक्का हार्मोनिक्स, फंडामेंटल हार्मोनिक के बाद थर्ड ऑर्डर हार्मोनिक 0 सीक्वेंस रहता, उसके बाद 5th ऑर्डर हार्मोनिक को बोल के 6k ± 1 बोले था, उसके बाद बोले था ये कुछ क्या बोले उसका याद नहीं आ रहा था, इसलिए पूछा सर आपको।
ओके नो प्रॉब्लम, याद रख के बोलना करेक्ट मुझे एक बार, वो कौन सा है पेज मुझे बता देना, मैं बोल दूंगा क्या है वो।
जी सर और एक कल आप इसके बारे में एक्सप्लेन कर रहे थे, ये एक बार देखे तो याद आने के लिए बोला, फिक्स हो जाना सर, ठीक है तो हमेशा भूल जा रहा हूँ ये।
यस
ये थिकनेस ऑफ लैमिनेशंस इज प्रोपोर्शनल टू 1/फ्रीक्वेंसी, ये थोड़ा बोलो सर, बोले था लेकिन भूल जा रहा हूँ सर, आप बार तो बोल सकते कहीं से।
थिकनेस इज इनवर्सली प्रोपोर्शनल टू फ्रीक्वेंसी है ना।
हाँ ओके,
क्यों, अगर फ्रीक्वेंसी ज्यादा हो तो थिकनेस क्या करना पड़ेगा, रिड्यूस करना पड़ेगा।
हाँ एज पर द फार्मूला,
हाँ थिकनेस रिड्यूस करने से उसका थिकनेस ऑफ लैमिनेशन कम हो गया ना,
हाँ कम होगी,
तब एरिया ऑफ क्रॉस सेक्शन भी कम हो गया ना, तब मैग्नीट्यूड ऑफ करंट कितना फ्लो करेगा एडी करंट उसमें,
बहुत कम फ्लो करेगा,
देन एडी करंट लॉस कम हो जाएगा। अगर फ्रीक्वेंसी ज्यादा हो तो, फ्रीक्वेंसी ज्यादा होने का मतलब क्या है, पॉजिटिव नेगेटिव ज्यादा आएगा,
रोटेशन ज्यादा कर रहा है,
देन पॉजिटिव नेगेटिव, दैट फ्रीक्वेंसी हाई मींस करंट positive negative will take place many times, then loss will increase.
हाँ अच्छा
okay अगर frequency is low then actually loss is less, then thickness को ज्यादा what you can do, if frequency is low then thickness you can increase। क्यों increase करना है, अगर thickness increase करने से lamination thickness size increases, cost of lamination reduces no,
हाँ
then why we are increasing thickness, anyhow loss is less, why loss is less, frequency is less।
अच्छा ओके सर ये क्या, और आखिरी का सर ये क्या है, तो ये एक छोटा सा इसमें ट्रांसफॉर्मर्स में आया सर, ये पॉइंट आया था इंडक्शन रिलेट का एक पॉइंट डाला था इसमें, क्या है कहता हूँ स्लॉट्स के बारे में बोला था सर, ये स्लॉट्स के बारे में क्या है कहता हूँ, हाँ लीकेज रिएक्टेंस इज हाई इन क्लोज स्लॉट्स and very low in semi closed slots and
yes
very
yes
very
ये
low in,
इंडक्शन मशीन में आएगा ये रिलेशंस।
हाँ सर
So,
वो
हाँ,
जी वो उसके बारे में मैं उनको मेल किया था सर, वो सर को एक हफ्ता से उन्होंने रिप्लाई नहीं दिए सर, इसके बारे में आप
इंडक्शन हो गया?
नहीं हुआ सर, ये पुरुष क्या बोलते हैं, इंडक्शन तो नहीं हुआ, लेकिन मेरा दोस्त ने डिस्कशंस के टाइम पे ये बात हुआ था कैसा का, तो ठीक है कैसे तो आज खत्म होती ना सर, आपको मालूम होता ना, तो ये थोड़ा बोलो सर, आपका रिलेटेड
सिंपल सिंपल। अगर ओपन स्लॉट है ना,
हाँ
ये स्टेटर,
ओके सर,
ये रोटर, इसमें ये कंडक्टर को प्लेस करना, करंट कैरिंग कंडक्टर। ओके, लीकेज फ्लक्स क्या है डेफिनेशन? द फ्लक्स व्हिच लिंक्स विद ओनली वन वाइंडिंग, उसे लीकेज फ्लक्स बोलते हैं।
हाँ सर,
मगर व्हाट इज आवर मेन एम इन इंडक्शन मोटर? व्हाटएवर फ्लक्स प्रोड्यूस्ड इन स्टेटर, ऐसे ले लेना क्लियरली,
हाँ
ये
स्टार्टर जी,
ये स्टेटर, ये रोटर,
जी जी हाँ,
इसमें करंट कैरिंग कंडक्टर है।
हाँ
so जो भी flux produced in stator it should reach rotor, that is our aim.
जी
But generally air, what is the air gap in induction motor? Very small, no?
जी सही है
Air gap is less, like this is rotor. Observe now, see, wait, this is a rotor slot, rotor it is, rotor body, stator body. See, this whatever the slot gap is there, this gap is let for example 5 mm it is, for example, or let us take some 2 centimeter better,
हाँ ठीक है सर
2 centimeter width। मगर ये जो भी गैप है इसका गैप लेस देन 1 सेंटीमीटर होता ऑलवेज।
हाँ ओके सर,
ओके 1 सेंटीमीटर। सो एज इट इज ओनली 1 सेंटीमीटर गैप, अगर current carrying conductor carrying current inside, no? Now apply right hand thumb rule, current inside thumb, flux is 4 fingers, then this flux is flowing like this, and out of this most of the flux lines will go to rotor only, very small amount is leakage here।
अच्छा,
अगर क्लोज्ड स्लॉट ले लेना, क्लोज्ड स्लॉट, इसमें क्या होगा, ये क्लोज,
हाँ
so, एक क्लोज होने से जो भी फ्लक्स इधर प्रोड्यूस हो रहा है ना, इसका पाथ मोस्टली इधर ही हो जाएगा, बिकॉज ये पाथ है ना क्लोज करके, आयरन है ना उसमें चले जाएगा, लीकेज ज्यादा होगा ना, जो भी फ्लक्स रोटर को आ रहा है वो कम हो जाएगा।
अच्छा
ओके
अच्छा वैसा,
तो क्लोज्ड स्लॉट में लीकेज फ्लक्स इज व्हाट मोर,
इसके लिए नो लोड पावर फैक्टर, प्राइमरी पावर फैक्टर कम हो जाता है।
राइट
सर, ये मैं सोच रहा हूँ कि ये क्या बोलते हैं बीच में का, आप जो ओपन स्लॉट्स में 2 सेंटीमीटर बोले था ना सर, वो गैप
स्लॉट विड्थ,
जी स्लॉट विड्थ बोले थे,
एयर गैप विल बी लेस देन 1 सेंटीमीटर
हमेशा, ये जो ओपन स्लॉट्स में
वैसा ही रहा,
क्लोज स्लॉट्स, कौन सा स्लॉट ले ले तो भी एयर गैप सेम रहता है इंडक्शन मशीन में,
ऑलमोस्ट लेस देन 1 सेंटीमीटर गैप।
अच्छा, वो जो लीकेज जो डेवलप होता है सो इन बिटवीन द स्लॉट्स।
यस
अच्छा ओके, थैंक यू सर,
ओके गुड, यस टेल मी।
Sir,
yeah tell me।
సో ఎస్టర్డే కరెంట్ ఇష్యూ వల్ల నేను క్లాస్ వినలేదు సార్, నేను విన్నాక ఒకవేళ డౌట్స్ ఉంటే కాల్ చేయొచ్చా సార్?
yes, first put me message in telegram, then
టెలిగ్రామా సార్?
నెంబర్ మెసేజ్ లేదు, ఇంత ముందు ఇచ్చాను కదా స్టార్టింగ్ లో,
నెంబర్ లేదు సార్, కాల్ చేస్తాను, టెలిగ్రామ్ లేదు నాకు, అందుకని
9392811678।
సార్
yeah Sagar,
వాట్సాప్ ఉందా సార్ దీనికి?
no only telegram, so that is there for my personal number।
సార్ మామూలుగా జనరల్ డౌట్ సార్, అదే ట్రాన్స్ఫార్మర్ ఎప్పుడైనా ఫాల్ట్ వస్తే అంటే పేలడం ఉంటుంది సార్, అసలు అంటే బ్లాస్ట్ అవడం కానీ అలాంటివి ఏంటి ఉంటాయా?
పేలడం అంటూ ఆ సౌండ్ అన్ని పేలడం మీనింగ్ అది కాదు. బట్ యాక్చువల్లీ వెన్ ఎవర్ సడన్లీ సమ్ ఫాల్ట్ వచ్చింది, అక్కడ మనకి ఐసోలేటర్స్ ఉంటాయి కదా, అవి ఓపెన్ అవుతాయి విత్ బిగ్ నాయిస్ తో.
అంటే మా ఇంటి దగ్గర ట్రాన్స్ఫార్మర్ ఒక్కొక్కసారి సౌండ్ వస్తూ ఉంటది సార్. అంటే పెద్ద పెద్ద సౌండ్ వచ్చి వెంటనే పవర్ కట్ అవుతూ ఉంటది.
జస్ట్ ఫ్యూజ్ ఫాల్ట్ అయ్యి మళ్ళీ బ్యాక్ వెంటనే వచ్చేస్తుంది కదా పవర్.
అంటే వెంటనే రాదు సార్, కొద్దిసేపు ఒక హాఫ్ అన్ అవర్ 15 మినిట్స్
మేబీ
పడుతుంది
ఆ
సార్.
ఫ్యూజ్ చేంజ్ చేస్తే వచ్చేస్తుంది. ఫ్యూజ్ బర్న్ అయి ఉంటుంది అంతే. ట్రాన్స్ఫార్మర్
సార్
డ్యామేజ్ అయితే
మళ్ళీ
అసలు పవరే రాదు కదా.
అంటే ఫ్యూజ్ అంత బ్లో అవుతే అంత పెద్ద సౌండ్ వస్తుంది సార్.
ఫ్యూజ్ సౌండ్ కాదు, ఆ బ్రేకర్స్ ఆ ఓపెన్ అవుతాయి కదా,
అంటే
ఐసోలేటర్స్ ఉంటాయి
బ్రేకర్స్
కదా.
ట్రాన్స్ఫార్మర్ దగ్గరలో ఉంటాయి సార్ ట్రాన్స్ఫార్మర్ కి.
ఐసోలేటర్స్ అక్కడే ఉంటాయి, అవి ఒకసారి చెక్ చేయండి.
సార్ మళ్ళీ ట్రాన్స్ఫార్మర్ టెస్టింగ్ చేస్తారు కదా సార్, అంటే మ్యానుఫ్యాక్చరింగ్ చేసినప్పుడు. అంటే అక్కడికి ఒకసారి వెళ్ళాను సార్. అంతే, అంటే టెస్టింగ్ చేసినప్పుడు కొంచెం దూరంగా ఉండమంటారు సార్. అంటే ఒక్కొక్కసారి
అంటే
ఇన్సులేటర్స్ అన్ని బయటకు
ఇండక్షన్
వచ్చే
అవి హై వోల్టేజెస్ ఉంటే ప్రాబ్లం. ఇండక్షన్
అంటే ఏమైనా
ఫినామినా కదా వర్క్ అయ్యేది.
అవును సార్.
ఆ ఇండక్షన్ వల్ల ఏమైనా మీ మనకి మొబైల్స్ ఇవన్నీ మన దగ్గరే ఉంటాయి కదా,
అవును
దీని
సార్.
వల్ల వాటికిలో ఇంటర్ఫరెన్స్ ఏమైనా అయితే అవి పేలిపోతాయి, సెల్ ఫోన్స్ కానీ ఇలాంటివి.
అంటే మామూలు మనిషి అంటే ఓన్లీ పర్సన్ కూడా ఉండకూడదు అంటారు కదా సార్ దగ్గరగా రేడియస్ లో. అంటే మొబైల్ ఫోన్ లేకపోయినా
హై వోల్టేజ్ ఉంటేనే ప్రాబ్లం. హై వోల్టేజ్ అయితేనే దే విల్ సే దిస్. ఎందుకంటే హై వోల్టేజ్ ఉంటే అప్ టు సమ్ డిస్టెన్స్ అయనైజేషన్ అవుతూ ఉంటాయి కదా.
అవును
జస్ట్
సార్,
లైక్
ఫ్లక్స్ వల్ల.
కండక్టర్ అయనైజేషన్ అంటే ఏంటి, స్పార్కే కదా అది.
అవును సార్.
అందుకే ఆ ప్రాబ్లమ్స్ ఉంటాయని దూరంగా ఉండడం.
అయితే బ్లాస్టింగ్ అలాంటివి ఉండవు సార్ ట్రాన్స్ఫార్మింగ్ లో.
నో నో నో.
ఓకే సార్, థ్యాంక్ యూ సార్.
Ajay, are you there? So, okay, I'm closing. Good night and take care.